So, should I publish the YouTube stream, or I think I'll wait until we are ready, because we are still speaking here.
Okay.
So I see that Julian joined, so I found him on the Tito. I had to add him as participant on the...
In Discord, yeah. part? Or...
Are you ready for this great conference?
No, no te voy a sacar las piernas.
Estoy... Say again?
If you're ready for this great conference. Is Miriam watching the streaming from the couch?
No, she has a PhD to finish. Hope she does.
Yeah, that's a nice thing to do during the weekend.
Yeah, she only has weekends.
I have a question. I just looking at people that are getting into the check-in, and many just say name and then like country or city. But I think at T2 there are no.
No, there's not. Yeah, I know.
No location.
I know. So if you cannot find exactly who it is, why can't I hear myself? Who is not?
It's maybe because of me. I will.
Okay, no
switch to
worries.
headphones.
So
you can send them like a private message and ask for the ticket code or for the the first name plus the surname.
Yeah, or they sometimes. Okay.
Okay, thanks.
There is no like specific list of people that are not participant, right? Just speakers and Olga.
Speakers are done. What do you mean? All the
I mean
speakers
the list of people that not done that we have to do because we are searching them in the check-in.
No, yeah, but only in the checking room, not in the list of, not on the list on your right. Only if they write to you.
Yeah.
I don't know about your experience with YouTube and the streaming, but if I'm connected to Zoom and at the same time I watch the stream, it sucks a lot of bandwidth.
Okay, so I don't know. Do I have permissions to let people in? Because I'm clicking. So I found the person. Yeah, and
you're an organizer. So you right click on the person, you go to roles, and you click on participant. It may take a bit to refresh.
No.
But don't you see the button or?
No, I don't see the button, or maybe I'm looking in the wrong place.
Yeah, you need to right click on the name usually. And then you have roles. It's the last part of the menu, last field. and then you can select.
I have like invite to server.
No.
Add note, profile, call, close DM.
So wait, because someone wrote a message to you, like a private message, right?
Yes.
So no, you cannot add him from there. You need to find the nickname inside the Remote Python Pizza channel. And then from there you can change the role.
Okay.
So there is a there is like a member list, there is a search field, you can put the name there. And then, I don't know, usually I click on jump on the last message from that user. And then I...
okay, participant. Okay, cool. Got it. Thanks.
I'll send an email with the live stream link. All right.
Cool. Hello, Mama. Can you hear me?
One question. We are here talking, and maybe we should go somewhere else to talk. We have a meeting voice room in Discord.
Makes sense. Do we want to keep like this channel clean?
I think it makes sense.
Okay, let's try. Is the meeting under admin?
Yeah.
Okay, let's move there.
So, yeah, which one?
The meeting.
Admin meeting. Okay, see.
So I'm talking from Zoom. I cannot hear Daria nor Timur.
You cannot hear me, right? From...
No.
Fuck.
Well, it's fine. We can chat as well in the boardroom. You can figure it out later. It's not urgent. but we cannot be speaking here in the Zoom channel.
It's very quiet.
So, how is it going? Hynek, nice background.
Thank you, thank you.
All right.
Can you hear me okay?
Yeah,
yes,
hello.
Yes.
Oh, cool.
We are waiting for Christian. I think he's preparing his slides.
Yeah, Alex, I think you can share your screen because my slides are not working.
Why?
I don't know, but Zoom doesn't let me share my screen.
I can share the screen.
Yeah. Hello, people, if you're watching the stream.
I'm sharing.
Yeah, I can see your browser.
Yeah, I'm sharing. I'm going to share the slides.
Can you hear me?
Yes.
Yes.
Awesome.
Okay, can you please so wait a second. We didn't train this enough, did we? So yeah, it's showing my full. So Christian, do you want to speak?
And you're gonna move the slides. So hello, people, and welcome to Remote Python Pizza. Please, next slide. So hey there, it's pretty nice to be here. I think people are connecting from all over the world, which is pretty nice. Alex, next slide, please.
Your slides are not on YouTube, by the way.
Alex, do we have technical issues here?
I don't know, man.
I think there is like a delay, Hynek. Could be.
There is a delay.
Yeah, there is like a 10 seconds delay.
I can't. Okay. Should we wait 20 seconds? Because I guess 20 seconds already passed.
So there is no stream there?
For me, it's dead now, so I don't have a live stream anymore.
20 computers here. Ah, shit. It's only me who can stream, right? My client is fucked up.
No, I can see the slide. Actually, I see my face. Sorry.
On YouTube?
Yes.
I see.
Yeah, I think it works. I think we can.
Okay, so it was a false alarm.
Yeah, don't worry. I think we can continue.
Or?
Next slide, please.
Can't be doing everything at the same time. So.
Okay, so we are the organizers. So there is Darian, there is Timur, there is me, there is Arthur, and there is Alexander. And the legal entity behind this conference is Peace Society, which is the organization that organized a couple of EuroPython, I think 2015, 16, 17 maybe. And the last edition, I think, of EuroSciPy. Nice conferences, a nice place where to go. Alex. So today we're going to have 50 talks. The conference is more than 20 hours, so it's pretty long, bring a lot of coffee. And I think we have more than 400 people, 456 to be precise. Next slide, please. And we organized this conference in about 30 days, so it was a bit of a rush, but I think we enjoyed the journey together. Next slide, please. Yes. So we call it pizza, but it's just another way to get together, which brings us to something really important, which is called Alex. The CSC, the Code of Conduct. So if you check the website, if Alex can show us the next slide, you can find the COC there. Please try to check it. It's not super long and it's really important. Next slide, please. So it applies everywhere. So please be mindful during your talk, your slides, your messages, Discord, and Twitter. So please, yeah, next slide, please. Try to be nice. I mean, otherwise we don't want to ban like anyone from Discord. And let's talk about money. So we decided to run this conference to do a sort of fundraising for Doctors Without Borders. And I think it went pretty well. So at the end, we raised more than 10K for Doctor Without Borders, which is pretty nice. And yeah, this is the last number from this morning. I think it's still growing, which is nice. And every penny, yeah, applause. And every penny will go, every penny will go to this NGO, which is pretty nice. Also, Tito or Taito decided to give the fees back, which is also pretty nice. We will try to do the same with Stripe, just to have more money. And yeah, every penny will go to, yeah.
Which one?
The next one. So Daria was in charge of the financial aid, and I think we did a great job. We gave away 36 tickets. So we have many people coming from abroad, and yeah, it was nice to help them, especially during these hard times. So let's talk about our official channel and chat applications. So we're using Discord. Probably you see many channels, but there are like a couple of them which are really important. So announcements. There is the QA part if you want to ask questions for the current talk. We have the info desk. We have the tweets where you can find the tweets from our Twitter account, and if you're using the hashtag #RemotePythonPizza. We have the vendor hall, but we also have the jobs channel. So if you're looking for a job or if you have open position inside your company, you can put something there. So do you love Twitter? If so, please use our hashtag, this one, #RemotePythonPizza. And yeah, it will be super nice to like your tweets or to retweet your tweets.
Are you retweeting?
Yeah, yes, I do. So it's the thank you time. So we want to say thanks to sponsors. I don't remember if we put the picture of the sponsor after this slide.
Oh,
Can you check?
We didn't.
Okay, you can check the sponsors on the website. So.
Oh my God. Okay. Should I name them?
Yeah. But I mean, we can do that together. So we have the piece, we have the EuroPython Society, we have Hippo, we have Wingware, we have Contact Software, Hambos, JetBrains. We have also NordCloud, this amazing company. We have Kite Consult, Vonage, Bloomberg, Petit Amsterdam, Text Kernel, Inform, which is also pretty cool, Solute, Transient Water, and at the end we have Königsberg, our last sponsor. So thanks, sponsor, for sponsoring this conference.
Next slide.
Okay, and thanks speakers and people who submitted a talk. That was super nice, which, you know, such a short notice, and we received a lot of proposals. So, I mean, without you, this conference wouldn't be possible. Thank you. What about the participants? Yeah.
Oh, sorry.
So thanks to you participants to hold the plus 400 people that decided to buy a ticket and join this remote event. And because the conference is pretty long, we're going to have a lot of MCs helping us and moderators to help you during the conference. So thank you to you as well. Oh, I have to say this one. I think it's your turn. Yeah.
Okay. Yeah. So anyway, I thought we should. I wanted to mention something. We lost a friend last week. He was the director of the Python Sebastian Society, and this is the first conference that we organized after he passed away last week. And yeah, so we lost a friend. We are a bit sad, but I hope that today this conference makes everything a bit happier. So we just wanted to say a farewell to him.
Yeah, he was really a great guy.
We also want to say thanks to Python 2 for 20 years of beautiful code. And we wanted to make 1 minute of silence for Python 2.
Starting from now?
Yes.
Okay. Do you think 30 seconds is enough?
It's 1 minute, mate.
Okay, sorry.
Are we in a hurry?
Oh, no.
Okay. 1 minute has passed. So keep going.
Yes. So, but last but not least, and please, the next slide. Did you order a pizza? I mean, it's fundamental. If you don't have a pizza today, I mean, you're going to refund your ticket. Next slide, please.
My dough is in the fridge.
Really? Okay, that's nice. So don't forget to share a picture of your pizza. You can use the cafeteria channel inside Discord, but you can also use Twitter. So don't forget to use the hashtag. And yeah, please, only pizzas are allowed. Sorry?
No. Go on.
Okay. So it's time for the first speakers. Hynek, are you ready?
Depends. Can you hear me?
Yes.
Yes.
So I think we can stop sharing. I can just say a couple of things about you. So you're going to talk about on the meaning of version numbers. I know you're a great surfer, a great skater, and I'm in love with Schlawack, all right?
Well, it's too much praise.
So a big round of applause for you. And yeah, you have the stage.
Oh, thank you. All right. Hello. My dear fellow pizza lovers, my goal for this wonderful UTC morning, I have to say, because we have people from overseas here. So my goal for today is to shatter dogmas, to question conventional wisdom, and to open your mind to reality. Is this a tall order for 10 minutes? You tell me in 10 minutes. This is the awkward moment when I switch to screen sharing. Here we go. All right, I'm Hynek, and I want to talk about the meaning of version numbers. And well, actually, I want to talk about semantic versioning, aka SEMver, which some people might have seen coming. So, semantic versioning, huh? Its makers set out for a very noble cause. They wanted to standardize version numbers and give them meaning, which sounds good. They usually come in 3 numbers, separated by 2 dots. The last number is the micro version, which you increment whenever you have a bug fix only release. In the middle is the minor version, which you increment whenever there's new features, but it's fully backward compatible. And finally, the first part, This is the major one. This is the major version, and you must increment it whenever you break backward compatibility. Unless the major version is 0, because then it's YOLO time. So now the theory goes that if you pin your dependencies a certain way, you can get only bug fixes, or you can get only bug fixes and new features, but nothing will ever break for you, which sounds great. But in my experience, it doesn't work as advertised in actual practice. And I have to stress here that I'm not here to shame anyone or even tell you what to do, because I could not care less what you do with your versions. As long as I can tell which version is the latest, I'm fine, thanks. But I want to warn users from living in a false sense of security, and I want to set maintainers free from the feeling of obligation to have to do semantic versioning. Now, why would I say something this harsh about something such beloved as semantic versioning? Well, firstly, semantic versioning does not deliver on its promises. Whatever you think you're getting out of it, it almost certainly is not true. Due to my time limit, I will focus on one main aspect, and it's the myth that you can just pin the major version and be safe. And this myth is actually very easily dispelled by a fundamental law of programming, which is known as Hiram's law. And it says that given enough users for every behavior of your program, and no matter how accidental it is, there's somebody who will rely on this behavior. And as a user, that somebody can be you, and it will be you probably at some point. And this is especially true in dynamic languages with its cavalier attitudes about ownership. You know, this unfortunately named consenting adults principle. And this is doubly true if you rely on subclassing, where namespaces get entangled and a change in a base class can bubble up to your classes and suddenly something doesn't work and you don't know why. Which is one of the many reasons why subclassing should be avoided and why you should listen carefully to Raphael later today. Now, as a maintainer, it's impossible to not break compatibility. From that, it follows that as a user, you cannot rely on any stability promises whatsoever. And in practice, it means that you have to treat every release as breaking anyway. So, and if a micro update never broke anything for you, it just means that you haven't programmed for long enough. So give it time, I promise you too will be blessed by this event. But not only is it pointless to pin your major numbers, it also can actually harm you. And the reason for that is that only very few open source projects actually have the resources to maintain more than one release branch, because it's usually just one person, maybe two. And what this means in practice is that if you pin the major version in your application, you just don't get security updates eventually. Sooner or later, they will just fizzle out, effectively freezing your application, the dependency in time for you. And the longer you stay in a false sense of security, the harder it actually gets to get out of there. And I say this as someone who spent many years with a Django pinned to 1.4. For packages, it gets even more problematic because you are gonna affect other people too. Let's assume that your package, named your package, depends on the most downloaded package on PyPI, which is your lib3 currently. And it's at 1.25.9. And your user of your package depends on it too, because it's a great package. I love your lib3. Now, to play it safe, you pinned it to smaller than 2.0, which means you pinned it to 1.x. Now, let's assume that your lib3 adds some amazing new features, as it does all the time, but also drops Python 2 because it's 2020. But it doesn't affect you in the slightest because it's 2020, so your package is Python 3 only in the first place. But to celebrate, your lib3 bumps its version to 2.0. Now, your users cannot update your lib3 to get those great features until you personally remove the pin from your package and publish a release. And if you're lucky, they will not notice because there's no way to know. But they will notice if they try to use another package. It also requires your lib3, but they require 2.0 because they are using those great features. Congratulations, you have just created a version conflict. And for no good reason, because if the change was actually breaking, they could pin your lib3 themselves. But now the pressure is on you because you have just disempowered your users. So what you need to do in both cases is actually something like this. You need to have good test coverage because tests are the only thing that will prevent breakage, period. You need to pin all your dependencies, including their hashes. and you need to regularly try to update your dependencies. And then you run your tests and see if they still pass. If they do, great. If they don't, fix them. Rinse and repeat. Semantic versioning will not free you from this loop at all. They only express the intention of the maintainers, but intentions don't matter when it's about the uptime of your web service, for example. And there's plenty of tools that can help you with this loop. So there's no reason to be afraid of it. Now, the second big reason I think that semantic versioning is bad is that almost nobody gets it right. And the underlying cause, of course, is that people seem to suffer severe physical pain from incrementing the major version. So how many projects do you know that exceed version 3? Do you believe they never, practically speaking, broke backward compatibility? Maybe they didn't want to, but they certainly did. And to give you an example from a project that diligently follows semantic versioning, which is setup tools, they are currently at 46.1. And for the record, I did not have to rewrite my setup.py 45 times. So much for the value of that work. Now, the extreme version of this is, of course, the prevalence of so-called zeroware, which are packages that claim to be production ready, but still support a 0-point-something version, which is just another form of fear of commitment and leaving an escape hatch, because again, 0-point-something is YOLO. So Semver is very clear on that. 1.0 does not mean perfect. 1.0 means ready for production. And a project, like a package, claims to be ready for production and claims to follow semantic versioning, but is at 0.75 or something. There's a contradiction right there. And a milder form of that is also quite common are packages that stay forever on 1.x. And what they do is not that they don't ever break compatibility. What they do is mental gymnastics to justify why a clearly breaking change is actually not breaking and it's not worth increasing major. But zeroware itself is so widespread, there's even a page about it. And it just maps all those packages on projects. To be fair, not all of them claim to do semantic versioning, but some of them are older than a decade. Now, you may be saying they are not just not doing Semver correctly. To which I say, this is exactly my point. Because I believe that a concept that most people get wrong is not a useful concept for most people. And it doesn't really matter why or the details. This is a systemic failure. And trying harder is never a solution to anything. Trying harder is highway to burnout and anxieties. Which brings us back to this slide. And please notice that I say most. I didn't say it's never ever good. I say it's not good for most projects. Some are thriving, like Django, but they have the resources to maintain multiple branches. And the fact that you cannot rely on pinning major version remains. So my point here really is that if you are a maintainer and you like semantic versioning, go wild. But if you struggle with this concept of semantic versioning, maybe you've been dragging a zeroware around for years or months and telling people, yeah, it's done, but I'm not comfortable to make it 1.0. Maybe just stop and withdraw yourself from this kind of pressure, because you can't lose if you don't play. And as I've hopefully shown, it's not really worth it either. So where do we go from here? First is, of course, always acceptance. And let's accept that in practice, version numbers mean nothing. So the C mark, it's less than 2 minutes. Now ask yourself, how do you convey the information about intended breakage instead? So for me, the answer, and I think it's a good answer, are policies that you say breaking changes will be announced a year ahead and will raise a deprecation warning until they happen. And then you have a changelog where you document what is gonna break, when is it gonna break, and how do you prevent those breakage. Of course, people will complain, but there is no reality where people will not complain about something. And this, in my opinion, is a very responsible way to handle things. As for versions, I have way too little time, but I'll give you some homework. And it is to look into calendar versioning. And the idea is that you take parts of the date and make it part of the version, which is surprisingly common even in real life. Like cars has part of their names forever. And it's surprisingly useful to see how fresh your dependencies actually are when you look at your pin files. And the most important part is these are actually facts. They are not guesses, not wishes, not intentions, facts. Now, I'm very much running out of time. So the takeaways. Don't believe the promises of semantic versioning. If your application breaks on a micro update, it's your fault, not the maintainers. Only pin major versions if you know it's broken and you're working on fixing it. As a maintainer, don't do semantic versioning if incrementing major gives you full body pain. And finally, try calendar versioning. Maybe you will like it. I do. And most importantly, please take everything I said with a grain of salt, because I only had 10 minutes and nuance is very difficult, and it's doubly difficult when done under pressure. So follow me on Twitter for more inconvenient truth. Learn more about calendar versioning from my friend Mahmoud, who made a page about it. Get your domains from Varimedia if you speak German. And this is all from me. Have a great remote Python pizza.
Thank you, Hynek. It was a great talk. I already see the tweet storm coming.
You sound surprised.
Okay, I mean, a big round of applause.
We have some applauses on the question answers.
Yeah, there is
Thanks,
the QA channel. And yeah, we are looking for the next speaker.
So, Wei Lee, are you ready?
Is Manav here?
Hello, should I join
Manav,
the
I think he's not
meet
here.
for now? Hi. Hello.
Hi.
Oh, hi.
So
I'm ready. So
yeah. Cool.
Okay.
So
Manav.
I'm afraid the video is stopped. So
Manav,
pardon.
Yeah. Yeah. So you can.
Yeah,
start.
I can do it. So Manav is not here, so we will skip Manav and we will go directly with Wei Lee. Wei Lee, can you hear me?
Oh, sure. Yeah, I can hear you.
You're going to talk about commitizen-tools.
Yep, that's correct.
What can we gain from crafting a Git message convention?
Yep. So
yes.
should I just...
you are connected from?
Should I share my screen now?
Yes, you can share your screen, but you're live from, you're streaming from? I'm still connected to run, so should I? No, I mean your location. Are you, I don't know. In
your I'm from Taiwan, actually.
Okay, that's pretty cool.
Got it.
Okay, yes, you can share your screen and then I will mute and stop my video.
Cool.
So yes, you have the stage.
Yep, can everyone see my screen?
Yes.
Cool. And thanks for being my talk. And my talk is about commitizen-tools. And regarding to my slide, it's on my speaker there, so you can scan in this QR code and find the link on my speaker deck. And I'll tweet the link on my Twitter later as well. And I'm Wei Lee, I'm a software engineer at Rockland Slice and a volunteer at PyCon Taiwan. And if you've seen the website of Remote Python Pizza, you might see my avatar as an anime character. So that's why I prepared this cap. Yep. And speaking of PyCon Taiwan, the end of our call for proposal will be tomorrow. So we are accepting remote presentation this year. So it will be your best chance to join PyCon Taiwan. So what is commitizen-tools? It's a GitHub organization that's contain a bunch of tools related to commitizen, which is a command line tool for committing rules. And commitizen CD template is a cookie cutter template to create customized commit rules. And we are going to create a few GitHub actions to utilize this standardized messages. And what I'm going to talk about, discuss why commit message matters and how we can use commitizen to help us with that, and how we can use these standardized messages. So if you just don't like to write meaningful commit messages and always use update when you run git log, you will see this kind of message that it says update, 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 and you'll never know what actually changes. So what is this bad? Because if your system is broken, it will be very difficult for you to find the right commit to roll back to. And second, if you send this pull request to a project, a reviewer will have a hard time to trust your change. And the last thing is you might tend to make lots of changes in a single commit, because most likely you use update as a commit messages because that's you don't know how to describe these changes. For example, you might add a lot of features and bug fix into a single changes. Yeah. And why should we write good commit message? Because a commit message convention can be a guideline for the team to know how code changes should be made in this project. And it's also self-reviewers time so that they can know your changes much faster. And it's also give the newcomer of this project a clear view of the involvement of this project. And so that they can get into the project much faster. So you might find a lot of guidelines about how to write a good commit message through Googling it. But yet it's easy to just forget this kind of guideline when you enter git commit and you see this window and you might just think, I will just enter update. So commitizen is here to help. First, I personally like to use pipx to install all those Python, all those tools implemented in Python. So in this example, I use pipx to install commitizen. You can use pip as well. And our command is cd, or you can type git cd to invoke commitizen. First, we'll use cd init to initialize commitizen and configuration. It's not actually needed for every user if you are just using our default commit rule without any other functionality. You can just skip it. But yeah, let's start initialize the configuration. First, we support two kind of configuration name, which is PyProject.toml and the cd.toml for non-Python project. Then this is the default commit rules. We'll talk about conventional commit later, and cd Jira is something related to Jira, and customize is one that you can easily configure this commit rule in your PyProject.toml. And because in this example we are using an empty project, there is no git tag, so it will use the default one, which is 0.0.1. And after that, you can see this is stated in your PyProject.toml. Let's get into the commit part. If you type cd commit or cdc for a shorter version, it will first ask you about the type of this change. So it can work as a hint for users to break down multiple changes into separate commit, which means you won't add a lot of feature and fix into a single commit. Then it will ask you to type the scope of this change, a short description of what change you have made, and whether it's a breaking change. And if you this may change a lot of things. For example, you are implementing a huge feature, you might want to write down why this is needed and how you achieve it. And the last thing is that I often use it to reference to a Jira tickets or the GitHub issue related to this commit. And after all this process, you can get commit message like this. And if you keep using commitizen to do so, you can find standardized git commits through git log. So what if I forget to use commitizen to do a git commit? We can enforce the commit check through pre-commit. We already implement a pre-commit hook on our project. So through adding this line to your pre-commit config, pre-commit will check whether your commit message follow our certain pattern. You can also customize it as well, but in our default configuration, it's conventional commit. And note that you need to install the type commit message pre-commit hook. And in this example, I type this commit does not follow the conventional commit as my commit message for this change, which obviously does not follow the convention. And after that, pre-commit will block you from committing because this message simply does not follow this pattern. And after that, how can we utilize these standardized commit messages? One of the things we are using is auto-versioning, and we are still implementing auto-generate change log. We already have a prototype that we'll discuss later. And thanks, Hynek, for the introduction about semantic versioning. Yeah. as he said, it's a major, minor, patch, or micro, and which can be mapped to incompatible API change and minor to the backward compatible functionality, and patch or micro for the bug fixes. And in our interface, you can see there is this breaking change question, which will bump a measure in semantic versioning. And if you choose no, and commitizen will detect which type of this commit is. And if you are featured, it will bump a minor version, and fix refactor and performance improvement would bump a patch version. And we'll still use this as an example. In this example, the commit with the highest version to bump is featured, assuming we don't have a breaking change inside it. And assuming the original version of the sample project is 1.2.0, and commitizen will bump a minor version of it, which will ensure 1.3.0. And sometimes you might need to specify version in your source file as well. And in this example, it's my project under init.py. And sometimes it would be quite useful to specify setup.py as well. And to specify version files in our configuration, commitizen will bump the version inside it as well. And since auto-generate changelog is still a beta feature, you need to install it. You need to install the feature branch on our GitHub through this command. And then our default template for changelog, we keep a changelog format. And then we are using the same example. Then if you run cd changelog on this example, it will generate a changelog like this. Because in our prototype, we skip commit that is neither feature nor fix. And in this example, we don't have a fixed type of commits, so it's not in our changelog. Yeah, that would be all for my talk. And thank you for your listening. And join us, and let's make commitizen-tools better. Thank you.
Okay, cool. Thank you, Wei Lee. It was a great talk. Alex, are you there?
Hi. Yeah, I'm here.
Welcome back. Nice t-shirt. So we have the next speaker here, right?
Yeah.
Mridu?
Yeah, Mridu. Yeah. Thanks, Wei Lee. Nice talk. I've been using Python semantic versioning, but I'll check commitizen-tools. Definitely.
Oh, thanks.
Alex, do we have any joke in the meantime?
Chapter jokes. Mridu is here.
Oh, cool.
Yeah. Hi.
Hi, how are you doing?
I'm good. How are you?
Pretty good. You're streaming from?
I'm from India.
Oh, that's very cool. Okay. So you're going to talk about memory address in Python, right?
Yeah.
Okay. Are you ready?
Yeah.
Okay,
I
cool.
will share my screen.
Yes.
Is my screen visible now?
Yep.
Cool. Just a second. Yeah. Cool. Can I start now?
Yeah, you can talk. You're streaming.
Okay. Hello, everyone. I'm Mridu Bhatnagar. I'm from India. And today I'll be talking on memory address in Python. So as I have less time, so I'll just skip my introduction and we'll start ahead with the topic. So beginning with, what exactly is meant when we say memory address? Everything in Python is an object. Each object gets stored in memory, and the location where the object gets stored in memory is referred to as memory address. So we all know that everything in Python is an object, and we are saying that the place where these objects get stored in memory is referred to as location, and we call that location as memory address. Now, through this diagram, let us see what is the exact meaning of that statement. So this rectangle that you see can be imagined as a memory block, and then this sub-rectangles that you see when I divide one memory block, these are basically the memory addresses. Each of this subblock is having one object stored inside of it. And then we know that in Python, we have variables. So variables in Python can be imagined basically as labels. So these variables are referring to this object. This is again a variable B. This variable is referring to object 2. So when you imagine as what exactly is memory address, this is the image that should come in mind. And the sample memory address is this unique ID that you see on the right-hand side. Moving ahead with the presentation. Now I use the term everything in Python is an object. So first let us discuss what is meant by an object. An object is an entity which has some metadata called attribute and associated functionality called methods. These attributes and methods are accessed via dot syntax. So in Python, when we use suppose object like built-in data structure as list, we know that there are various methods associated with the list like dot append, dot extend, list dot sort. These are various kinds of methods. Along with the methods, there are attributes. So what we need to remember is everything in Python is an object, and every object has these main 3 things associated with it. So this can be imagined as an object. The drawing that you see, just see at my cursor. This is an object. Each of the object will have its own type. Type as in when you initialize a string and type on your interpreter, type parenthesis the object, then it will tell you what type of object it is. Another is value. So suppose when I do a is equal to 1, that value is 1. And then identity. Identity we'll be discussing in coming slides. And just let us quickly code it, what I mean. So I initialize a variable a with an integer value 1. Then I do a type of a. A is initialized with an integer object. Type a, when I do, it is telling me that it is an integer. I can do an ID of a. ID of a gives me a unique memory address. And then value, we all know that value is 1. So when such a statement is written, first the object gets created. Once the object gets created, then this label that you see, the variable, refers to that object. Whenever we discuss memory, that illustration that I showed you is something that needs to be remembered. Moving ahead. The next question that comes to mind is, okay, since so long you have been talking about memory address, now how do we exactly determine the memory address of an object? So far we discussed what is an object, what is meant by memory object. We went through the illustrations. Let us find out how we determine the memory address. In Python, there is a built-in function named as ID. The syntax is ID parenthesis and here object. So object can be list, string, or anything. And as stated, object accepts a single ID, accepts a single parameter and returns identity of an object. Identity returned is unique. So as we just did in this interpreter, let us redo it. I can do a is equal to list 1, 2, 3. I just did an ID of a. This returns me a unique value. This unique value is the memory address. Inside the memory, at this memory address, this object has got created. Object list object 1, 2, 3. So the meaning of all that is written is this. And then this is one of the very often asked question by the in the interviews, that what is meant by mutability. In Python, we often use the term mutable when we discuss about list, dictionaries, sets. So what do you mean by mutable? So mutable in plain English means changeable. So here in Python, mutability refers to we can change the content of these built-in types without changing their memory address. I'll repeat it. We can change the contents of list, dictionaries, and set by keeping the memory address as same. So this can be checked out here. Just quickly do it. I did a L 1, 2, 3. Let us see what is the ID of L. We got this ID. Now I want to increase, I want to add an element to L. I did L dot append 4. And when I again do L, we can see the list has got changed. When I do ID of L, you will see that again we have got a memory address. Now when you observe the first memory address of this list and the memory address that came after modifying our list, both these memory addresses are same. So list is a mutable object, and when this mutable object, we tried adding something to it, we saw that we changed the content of the list, but the memory address remained same. Likewise, as we discussed about mutability, the next thing that comes is immutable. So immutable is just the opposite of mutable. So mutable means changeable, immutable means not changeable. Now, what this means is we cannot change, whenever we will change the content of any immutable object, the underlying memory address will also change. So let us quickly do an example. I have a string with me. S is equal to, I did a Python pizza conf. Let us try this. Now I want to capitalize that P. I just try doing that. And you see, we cannot do that. Why we cannot do such kind of initialization? Because as we all know, string is immutable in Python. So that thing has got rejected. And if I have to change something, I'll have to reinitialize my string. So S is this. I did a ID of S. ID of S is, now you can see that there is this ID has got returned. But if I again change this to something else, IDS. See, I initialized the string twice by making the change to the initial character. And you can see here that both the memory addresses now have become different. So this is meant by immutable. And this one quick interesting example is, if I take a tuple and inside of a, so remember tuple is immutable, but inside of a tuple I am taking another mutable object, that is list. Now I'm trying to see what is the ID of this list. So ID of list 0, 0, 1, 2, 3. I do. You can see this is the memory address. Now, if I append anything to the list, let us append 6 to the list. I do a S3, 3, 5, 6. 6 has got appended. Let us see the ID again. Oh, I capitalized the S, sorry. Yeah, now you can see both these IDs are same, even though our main outer structure was a tuple, but inside it we are adding an element to the list. So list being mutable, that ID has reference, memory reference ID has not got changed. So these are some of the examples of what happens when we are exactly dealing with mutability and immutability. And we are short of time, so I cannot discuss all the examples here, but I can continue this interesting examples on Discord. So And before we end things, let's try to connect the dots. And this is an interesting question. When to choose is versus when do we use equal to equal to? So let us try connecting the dots backward. Is used for checking whether the identities of two objects are same or not. So if I do A is equal to 1, an ID of A, it would return me an ID. If I do B is equal to 1, it would give me B ID of B. So as we can see, both IDs are same. So when you do A is equal to B, it would return true. While equal to is double equal to is used when basically you are comparing the values. And this is another example. Can memory references be copied in Python? So here is a fun example for you to try out. So I initialize a list in 3 sublists inside of a list.
We are running out of time.
This is the last one. 2 minutes? 1 minute, okay.
30 seconds.
Okay, yeah. I'll close this one. So I initialize it with A001, and then all you see is instead of the value getting changed at A00, at other places also the value has got changed. So now it is for you to figure out why the next 2 values have also got changed. So if you have followed through the talk, you would be able to find an answer to it. If not, I'm there on Discord and we can discuss it there. So thank you.
Thank you for your talk. Alex, do we have the applause?
No, well. Thanks, Mridu.
Thank you.
Okay, I think we are like 5 minutes ahead of time.
Yeah.
Alex, do you want to tell me something about your pizza? You were talking about the dough before.
I have to, so supposedly I have to take the dough 1 hour before putting it in the oven.
That's nice.
But I'm not sure if I'm going to have it for lunch or dinner since I'm going to be the whole day here.
Oh. Margarita or something else?
I don't know.
Pizza? Okay.
We have some anchovies, maybe.
Okay. Okay, good.
Sorry if I
touched my feelings.
Yeah, touched your Italian feelings.
Yeah.
Any tractor joke from the people in the Zoom channel? No, Mark Smith is not here.
I have a joke like I'm reading this one, so I don't always test my code, but when I do it in production.
Well, that's a Chuck Norris joke. Without Chuck Norris.
What else?
So, yeah, this first hour was a bit stressful. Discord is still
like firing. I mean, yeah, this morning we were dealing with Zoom problem connection and this sort of things, but I think it's doing well, no?
Yeah, I had some people hearing some background noise on YouTube. They messaged me, say, hey, there's some noise on YouTube.
I think it's really strange. Like, was it coming from my microphone?
I don't know. Why? Do you have
just
people
joking,
in your room?
Because yeah, you complain a lot about my microphone and about the sound of my microphone.
Professional. Your professional microphone.
So we have 4 more talks before the first break, right?
4 more talks. Exactly. We have Jayesh, then Hwee, then Olga, then Daniel Pope. Yeah, folks. In 3 minutes, we should start with Jayesh. Fake news foe. I think he's here. Cool. So let's talk about the elephant in the room. How is confinement?
Why do you want to talk about this thing? Like it's There's no confinement. I can go out. I have the balcony.
I don't.
Oh, you didn't have a balcony?
No.
It's time to change your flat, man.
Not yet. Munich is
just a couple
so
of months.
Expensive.
Yeah, yeah. But you can move to the north, right? Here, life is pretty good in Berlin.
Tell my boss.
You do have an office here, no?
No, we have remote colleagues there.
That's also good. That's the future. That's what I hear every day.
So
I'm looking for nice jokes, but nothing is really great. Oh, this one is good. There are no bugs if you don't write any code. Wasn't that good?
pip install py jokes.
Okay. So we are almost ready for the next speaker.
Yeah, Jayesh, fake.
Yeah, hi, Christian. Hi, Alex. Good morning.
Hi.
Hi there. Are you streaming from?
Yeah.
Yeah, but you're streaming from. Where are you located right now?
India.
India right now.
Oh, that's pretty cool. Okay, great. Alex, what about you?
What? I'm in Munich.
Oh, share your location. Okay. How is the weather there?
Sunny.
Sunny, that's nice.
Yeah, but it's 18 degrees or so it's fresh.
Okay, Alex, do you want to introduce the next speaker?
So the next speaker is Jayesh. He's going to, the title of his talk is Fake News Foe, Fighting Fake News with Python, Machine Learning, and Twilio. Sounds good. Thanks, Jayesh.
Should I start?
Yes, you have the stage and you have 10 minutes.
Sure. So good morning, everyone. Hope you guys are fine and coping well with the lockdown. So today we will discuss about fake news for how we can build a chatbot with a Python, machine learning, and Twilio, which can help us combat the fake news as an issue. So talking about me, I'm Jayesh Bapu Ahire. I work around machine learning, cloud, and I love coding in Python. You can find me on Twitter at Jayesh_Ahire1. If you have any projects or if you want to discuss something, you can hit me up over there. Talking about fake news. So as Wikipedia defines it, fake news is also known as junk news, pseudo news, or hoax news, and is a form of a news consisting of deliberate disinformation or hoaxes spread via traditional news media or online social media. So today we are more concerned with the online social media, as that is the thing spreading this kind of fake news and impacting large amount of population over there. So why we need this, or why we need this kind of projects? So fake news is a major issue in digitally connected world. So when we talk about the impact of the fake news, so single share on your social media can impact millions of the people out there. So in a country like India, the fake news has caused so many of the riots and lynchings last year. So the fake news which is spreading via WhatsApp or any kind of a social media is impacting many lives in real world. So this is a major issue, and many people are trying to combat this issue using various technology and various techniques. But even though like companies like Google and Facebook are working on this, but there's no easy to use solution over here. When we talk about easy to use solution, we are talking in the user's perspective. So there's no easy to use solution for the user to the robust easy to use solution which user can use easily and find if the news is a fake or not. So can we as a developer turn to machine learning and solve this problem, which can make the world a better place? So talking about using machine learning for fake news detection. So this whole thing is more catered toward machine learning, but we will move to Python as well. When it comes to machine learning, there are two different parts we want to discuss: so feature extraction and model construction. So when we talk about feature extraction part, we will have to consider two different major categories for extracting features: news content and social media content. Talking about news content, vocabulary, phrase structure, and writing style are some of the factors we consider, or some of the features we can consider while while creating a data set for the while extracting features for the model construction. So when it comes to fake news, the writing style differs, so it follows some patterns. Like if you get some free offers, or if you get some communal news, that might be the pattern for the fake news. Then when we talk about social content as a feature, there are so many aspects of the social media profiles or the publisher's profile which comes into picture when we are categorizing news as a fake or not. So suppose I have a million followers on Twitter. I don't have those, but suppose I have million followers on Twitter and I post something. So that might be created by too many people, and if people started retweeting it, and if it's a fake news, that might impact more people. Similarly, users' opinion on this. So suppose any news media agency publishes an article, and I want to check if it's a fake news or not. I can consider what users think about it. So suppose I share that article on any social media. So how many like it got, how many retweets it got, or how people are endorsing it, and what opinion people have about it can be a feature for the for identifying if it's a fake news or not. Similarly, friendship and diffusion network. So when it comes to social media aspect, there are in your network there might be 1, 2, or 3 layers, like close friends, then friends of friends, and rest of them. So when you share something and your friends endorse it, so that will be a friendship network, and similar thing goes for the diffusion network. So this kind of features we have to consider while constructing the model for the fake news detection. So when it comes to model construction, there might be different kind of models for the different purposes we are serving. Based on news context, there will be fact-checking model, which will only tell you if the given fact or given headline or article you are giving to a model, if it's true or false. So it's just a 1 or 0 types of binary classification model. Then there comes a clickbait detection. For the clickbait detection, there will be some patterns we are identifying again, and according to the pattern, we will go for the detection of the fake news or not. Then there's a stance-based detection which we are using for this project. We will discuss about stance-based detection in the further slides. Again, going to social media context for this, there might be trolls or social bots detection, and then there might be fake news propagation patterns. So identifying these patterns will help us identifying if the given news is a fake or not. So let's jump into the setting of things and see what requirements we have for the project. First thing you will need is a Twilio account. You can sign up for one for free or here. So I will share the slides and you can go this link and sign up for one account. You will get free credits as well. There's a Twilio WhatsApp sandbox which we need to configure with the webhooks. Then we need to set up a Python and Flask developer environment, and we will also need Nbox so we can tunnel into our local host server. So we are building 2 different models over here. First is like basic fact detection or fact checking model, and second will be your advanced fake news detection model. So in first one, we are using liar data set, and the liar data set basically has 14 different columns. So we are streaming them down into 2 different columns. One will contain the news headline or text, and the second column will contain a label for the particular news, if it's a true or false. So this will be a supervised kind of approach we will be following. If we train our model based on this, we will get a supervised model which can detect whenever we provide some headline, it will detect if it's fake news or not. Then the second model we are creating is a stance-based fake news detection pipeline, where whenever the new article comes in or new social media post comes in, we will feed that post into the model, and now we have a link for the article or headline for the article or keywords extracted from those. We will go to a search engine, search for all the pages which have the similar keywords, and then we will rank them according to their credibility. So suppose for the particular keyword, we got 5 articles which match the context which is there in the news article we are searching for. So the higher credibility will have higher weights as well. So suppose 3 of the so in this case we can see 2 of the higher credibility news articles disagree completely with the fact, and one says it's neutral, and then one of the 2 low credibility articles, one of them say agrees with the fact and the other one disagrees. So we can just go for the summation, and if 3 here the 3 of them disagree and one of them is neutral and one of them agrees with the fact, so we can go and say it's a fake news. So this is more robust approach to detect if the fake news or not. So for the code, you can go on the GitHub, and the code is live. You can go and check it out. I will also post the link on the Discord. So let's just jump and see how we can set the things up. So here we okay. So when we got first liar detection data set, then we did some further pre-processing, then feature selection part as I discussed, and then there will be classifier creating various classifiers and testing them for the for the various test cases. So while setting up the things, this is our final Flask app, which we will be accessing from the Twilio WhatsApp API. So here, whenever the new message comes in or new article link or article headline, whatever comes in, it will go to the inbound message. We will send that inbound message as a parameter to the detecting fake news function, which is in the prediction, which will predict the label, like if it's a fake news or not, along with the confidence. And then we will send a response like the news headline you entered is true or false, fake or not, and the corresponding confidence level. So for the sake of time, I have this app running over here, Flask app, and I also have the ngrok URL. So you can obtain the ngrok URL by running the command /ngrok http 5000. So you just have to copy this ngrok URL from here, and you can go to Twilio console and paste the URL /SMS, which is your endpoint for the Flask app, and just hit save. So when you are done with this, you should be able to get something like this. So whenever you will send a message, like here I'm sending like Twilio is a cloud communication company, and the response I got is a news headline you entered is true, and the corresponding confidence level. So if you want to test this thing, you can just go on this QR code and send a message, join hidden city. So I will show you that. So go on this the QR code will redirect you to this number, the +1 415 523 8886. Send a message, join hidden city, and send any article link or any article headline, and you can get a response if it's a fake news or not. So I guess that was all for me. Thanks guys. If you have any question, I'm available in the Discord, as well as you can hit me up on the Twitter at Jayesh_Ahire1, or you can mail me at jayesh@trinity.tech. So thanks Alex and Christian. You guys can take this over.
Thank you for your talk. It was great.
Thanks,
Alex. What about the applause?
I still haven't found a nice app. I don't know.
Actually, I had the app on my phone, and then I started to play the applause, and then I got like the advertisement, which wasn't really nice in the middle. So
yeah.
And I don't feel ready for an application for the applause, but I can send you the invoice, right?
Sure.
Okay. Are we ready for the next speaker?
Xinhui? Or you ready? Is she listening? Yeah, she's.
Yes.
Hello.
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 How are you doing?
Okay. Yeah. No, I'm so lost. It's actually in the evening right now. I can't buy my pizza myself because I'm speaking. So I asked people to help me to buy pizza, but I don't think they are in the mood for pizza today. So maybe I might have to order it for supper.
Don't worry, next time. And you're streaming from?
Singapore.
Oh.
So that is like, yeah, same time zone as Taiwan.
Okay.
Good to know.
I know.
Hey.
Should I say good morning or good afternoon or good evening?
It's good evening right now.
Okay.
Not good night, please. Not good night.
Okay, it's not good night yet. Okay, so you're gonna talk about Numba, just in time with Numba, right?
Yes, just in time with Numba.
So are you ready? You have the stage and you have
the
10
screen.
minutes. Yes.
Okay, then wait. Okay, wait. Stage. Okay. Oh, let's go. Share screen. Okay. Okay.
Cool.
Okay. Hello, everyone. Yeah. So I'm Hwee from Singapore, and I will be talking about just in time with Numba. Yes. So a little bit about me. I am a data engineer, and I have a background in aerospace engineering as well as computational modeling. So as a data engineer, I have to interact a lot with pandas. So as a way of giving back, I contributed to documentation for the Pandas 1.0 release. And besides my open source work, I'm also actively involved in the developer community in Singapore. And I am a mentor at Big Data X, a volunteer community which conducts hands-on workshops in data engineering for interested professionals. Okay, so as a data engineer, I'm heavily involved in quite a number of data science projects. So there are often a lot of bottlenecks in a data science project, one of which is actually the lack of data, or the data quality is actually quite poor. So because of that data quality issues, it is essential and necessary for us to conduct data pre-processing. So it is a common adage that the data science workflow follows the 80-20 Pareto principle, 80% pre-processing, 20% analysis and modeling. But the problem is that in reality, due to the data quality issues, sometimes the data quality is really horrendous. You end up spending almost 90% of the time doing your data processing and manipulation before you can actually use the data to train your models. And on top of that, in the data science team, we primarily use Python in our workflow. But Python is infamous for slow processing speeds, especially for loops. So we always hear about Python for loops being excruciatingly slow compared with C. Why is that so? This is because Python runs on the interpreter and it's not a compiled language. So what do we mean by a compiled language? This is where we will have to go to a deeper dive on how compiled languages work versus interpreted languages. So in a compiled language, the written code is translated to compiled code in the target language through a compiler. So imagine that you have a C++ code, and then I compile it first, right? Then it will be in a target language. So after some intermediate steps and stuff, and then the code is ready to go through a linker, whereby the linker links all the components together, processes it, and then it generates the machine code, which is loaded into memory for execution by a loader. So that's how compiled languages work. So which means that your code is that when your code is ready, you compile it one time, you have the executable, and then you just load it and run. That's it. However, it does have its disadvantages is that when I make changes to the code, right, I will have to compile it again. But the benefit is that once my code is done, it is in machine code. Right? I can compile it in machine code. Done. It's a one-time effort. So when I run it repeatedly, I will just need to run the executable. However, for interpreted languages such as Python, we have the written code that is translated through a compiler into lower level bytecode. The lower level bytecode is then loaded onto a virtual machine for execution. So all this happens at runtime. So in contrast, right, with in compiled languages whereby you're actually running the executable at runtime. For interpreted languages, you have to go through all these steps at runtime to execute our code. So while this form of code execution provides flexibility in that we do not need to compile our code manually every time we make changes to the code. So let's say I want to make some typo, then yeah, I just make a typo, I just change it. I don't need to compile the code again. I just run it and then it works. But then the flip side is that every time I try to run my Python code, I will have to go through this whole bytecode translation every time, even though I have not made any changes to the code. So all these overheads will add up to the perception that running Python codes will be, they seem to be slower compared with compiled languages. So we have compiled languages whereby I have to compile my code every time I make changes. I have interpreted languages whereby I have to keep going through the bytecode translation. So the compromise is that, I mean, it's not really a compromise, but it's more of like an in-between between compiled and interpreted languages. So there's a concept of just-in-time compilation, or JIT for short. So what is just-in-time? So just-in-time converts source code into native machine code at runtime, and it is actually the reason why Java runs on a virtual machine, which is quite similar to interpreted languages like Python. But then, in contrast with Python, it actually has comparable performance to compiled languages. And how do we implement just-in-time compilation in Python? We will implement it with the Numba module. So Numba is a JIT compiler for Python that converts Python functions into machine code. And how do we apply it is that it can be used by simply applying a decorator or a wrapper around functions to instruct Numba to compile them. So this is in contrast to Python, whereby I will have to manually add in the types in my Python code to compile them. So for Numba, there are two modes of execution. One will be the NJIT mode, which is also known as the no Python compilation of Numba compatible code. Another mode of execution will be the JIT mode, which is also known as the object mode compilation with some loop lifting to optimize loop performance. And if we want to take a look at what is the difference between NJIT and JIT, we'll have to take a look at what goes behind Numba, which is basically the Numba compiler architecture. So the Numba compiler architecture is based on the LLVM-like library, which in turn is based on the LLVM compiler infrastructure. So the core of LLVM, like how LLVM actually works, is that it makes use of intermediate representation, also known as IR, which is a low-level programming language similar to assembly that is portable and conducive for further processing before being used to generate machine or object code for a target machine. So what we find is that, okay, so because as Python bytecode is untyped before execution, so how do we go from untyped Python bytecode to machine code? Because we need some type interpretation, right? So that's why we have the Numba IR, which is used as an in-between code representation that is more amenable, more flexible to further manipulation as compared with Python bytecode. And if we look at the Numba architecture, we can actually separate it into the front end and the back end. So the front end will infer the typing, and the back end will generate the native code for the machine based on the typing. First, the Numba interpreter will analyze the Python bytecode and translate it into Numba IR. After going through some optimization and transformation, the Numba IR will go through a type inferencing engine to assign types to the intermediate variables in the Numba IR. After going through the type inferencing and for some further optimization, Numba will attempt to generate specialized native code in a process known as lowering, and will translate IR code, the Numba IR code, into native mode or no Python. Basically, it could be the native mode or the no Python LLVM-IR by using helper classes from the LLVM library. So that is actually the mode that Numba aims to convert the code into, which is the no Python mode, native machine mode. But sometimes you may have some Python functions that is not compatible with Numba, which means that that Numba can't identify the type for that function. So if I can't find if I can't find any of those compatible types, Numba will translate the code into object mode LLVM-IR with some loop lifting to actually optimize the performance. And then after going through the lowering process, which is also known as the code generation process, the generated LLVM-IR is then compiled by the LLVM JIT compiler into machine code, which can then be loaded into memory for execution. So after talking about the nitty-gritty details of what Numba is and how it works, let's look at the practical implementation to see how easy it is to use Numba. Okay, so first, in the following example, I will illustrate the use of JIT mode of execution in Numba. So in this example, the objective is to standardize and resize images in an image data set before training an image classification model. So there are around 1,400 images in this train normal directory. So the first thing that I have to do is to initialize the file list in the directory before I define the image processing function. So the image processing function would take the file name as an input, open the file, and then do the processing. Okay, so with Numba, right? And then you look at the function, which is called ImageProc. What my objective is to convert and resize the images. So first I open the image, then I convert to RGB, and then after which I resize the image to a standardized form. And then you notice that I use from Numba import JIT. So in this example, the code runs in object mode. And with Numba, JIT mode, when I run the code on the Python interpreter without the JIT decorator, the execution time is actually close to 220 seconds. But after object mode compilation with Numba, the execution time is actually shaved by more than 20% due to the loop lifting operation which Numba executes. So why do I use JIT and not NJIT, you may ask? Because in this case, since the pillow image type is not a Numba compatible type, Numba will have to resort to the object mode execution, and the code will run in the object mode with some access to the Python interpreter to run the PIL code. In the next example, I will be illustrating to you how to use the NJIT decorator, also known as the no Python or native machine mode of execution.
Chin, you have 10 seconds. You have 10
okay.
more seconds.
Okay, so right now, right, I just want to convert I calculate the square of the number in the list. And in this case, it runs in no Python mode because Numba is a Numba compatible mode type. And in this case, right, the speed up is almost 100% with the compilation. So some key takeaways: JIT compilation with Numba converts source code from non-compiled languages into native machine code. It may not work for some functions, and it significantly enhances the speed ups provided by optimized numerical codes. And yes, so you can find my slides on GitHub over here.
Cool. Thank you for your amazing talk, Alex.
Thank you. I don't think it will sound good.
It's super bad. It's super bad. Again, thank you for your talk, Chin. Yeah. Enjoy your weather there. I don't know what you plan to do right now. Please join the stream and yeah, the other speakers and the other participants.
Yay!
Thank you.
Yeah.
Thank you. I joined the stream.
So we have Olga here. Olga?
Yes, can you hear me?
Yes, loud and clear.
Excellent. Okay, let me find how to turn my camera on and share my screen. Hi, can you see me?
Yes, you're streaming from?
So, I'm currently in Greece.
Oh, that's very cool.
Yes.
Nice weather.
Okay. That's what I would think as well, but it hasn't been very good the past few weeks.
Okay. Oh, that's sad. Okay.
Okay. Okay.
So, social distancing from your system's dependencies in a healthy way.
Exactly.
That's your talk, and yeah, you have your stage. Everything is ready. Yeah. You have 10 minutes.
Excellent. Yes, thank you very much. Can you all view my screen well? Is it full screen for everyone? Okay, good. Hi, everyone. Thank you, Christian and Alex, for the introductions. Today, I'm going to be talking about a current topic. Since we have all been exercising social distancing in our lives very effectively, we're going to see how we can apply it also in our systems dependencies. A little bit about me. So my name is Olga, and I was born and raised under the Greek sun. Although I currently reside in London, I'm not there at the moment, but I work there as a software engineer for Bloomberg, which means that I spend a lot of my time debugging C++ code and occasionally writing some Python code. I studied electrical and computer engineering, and then I switched to being a software engineer. And I spend my free time swing dancing when that is allowed, and nowadays burning things in my kitchen. Today I'm going to share with you a story of a Python service written by C++ developers, also known as my team, and the struggles that we went through when we had to write our first Python service ever. So we were writing scripts and tests with Python before, but it was the first time that we had to write something really used by clients. And this is what we had envisioned. We're gonna have just define one function, it's gonna take the arguments we want, it's gonna do the stuff, and it's gonna return the stuff. And that worked actually pretty great until we had to test our service. And that is when our continuous integration platform was not very happy with what we had created. Because although we knew how to write code, we didn't know how to test effectively in Python. And we hadn't managed to apply the social distancing from our dependencies, so isolating them and testing what actually we wanted to test. So it ended up that all our tests, unit tests, integration tests, were looking more like end-to-end tests. And of course, we couldn't apply automation because the continuous integration wasn't working and things were breaking and everyone was really, really sad. And as I cannot get into more details about what happened with that service, I'm gonna use another example. Let's say we want to create a cinema application where we want to get movies from the movie database API, and we want to rate them. And we have very strict rules about how we want to rate the movies. So we want to check who the director is, and if it's a Quentin Tarantino movie, we're gonna give it a 10, and we're gonna give a 3 to everything else. Let's start by taking things simple. First, we want to create this new service that fetches movies from the movie database API. So we're gonna send an HTTP request to get back a response with the movies, and we want to put it in a nice dictionary where we can have all the details. So we have an application called Great Movie, get and rate movies, and it's just gonna call this API and it's gonna return the dictionary. Then we want to test this. And how would a simple test look like? So you can see at the bottom, we define our test. And since we make a request to an external API, the good thing is if we want to have this in our continuous integration platform is to mock the path that it makes that request. So we're gonna use this, the lovely module unit-s.mock, and we're gonna use mock.patch to patch that path that is making the request. And at the top, we define, we are mocking a kind of response that we expect from this API. So we need to specify it exactly how it would look like, as our application depends on getting these values back and then creating the dictionary that we want to return to our client. We can then parameterize a test. We can add more tests where we can expect empty results. We can have side effects, expect failures, connectivity issues, everything. So far, this looks okay. It is somehow readable, and we know we can do a lot of things with it. But what happens when we want to enrich our application and we want to add features? So now we want to get the movies, but the response from the movie database API doesn't return as the director of the movies. It returns only the IDs. So we want to fetch the names. After that, we want to do some magic filtering and not rate all of the movies that we get back as a response, because then they will catch us that we are doing something nasty. So we're gonna apply some filtering, calling another magic service that we have also developed on the side. After that filtering, we're gonna apply our magic rating algorithm, which is, again, if it's a Tarantino movie, give it a 10. If it's anything else, give it a 3. And then we're gonna post back that movie rating using, again, the movie database API. So this is the whole code of the service that we need to write. It's very few lines. It looks good. We have other 3 functions in the same file that are doing all the calls for us. And we can count that we have 5 different calls. 3 of them are to the movie database API, 2 to get, 1 to post, and 2 to the magic API, our own magic API, that to do the magic filtering and to do the magic rating. So now we have written our application. How are we going to test it? Are we going to patch it up? How many context managers can you have in one test if you have 5 calls that you need to mock? This is an example of how a test could look like. So I didn't even try to put the context managers, but having 4 decorators, 2 for the requests and 2 for the magic API, the get request would have to be parameterized, of course, because we have 5 different calls. This is not a very good looking test. What if we have also different arguments, other responses, empty responses, failures and exceptions? We want to test what our service is doing, and we are going to end up with huge files and files of tests, passing all the decorators and defining everything like that, while we don't really care about exactly what the APIs are returning. We just care that they are returning something. So this is when also in real life, we had to rethink our tests. And we went, of course, to Stack Overflow and Googled, how do you write unit tests in Python? And we found out that someone on Stack Overflow said, every time you use mock.patch, it means you have a design flaw in your architecture. That was very insulting, but it made us think a lot. And it reminded us also of something we knew. It says, don't mock what you don't own. Mock.patch ties you to specific implementation details, but this is not what we were trying to test. We're trying to test if our application was doing the right thing, if it was making the right calls, getting back the correct dictionaries that we cared about, passing it around, and retaining the correct result. And then we decided to go back to our C++ roots, and everything that we have been complaining about C++ came again to play. And that is nothing else but dependency injection and combining that with the adapter pattern. So for those who are not familiar with dependency injection, is a technique where an object supplies the dependencies of another object. And instead of the client specifying what service it will use, something else as a client what to use. And the adapter pattern is nothing rather than a thin wrapper that provides an alternative interface for a class or API you're trying to use. So you are converting something incompatible to something that is a bit more compatible. And applying this, these 2 different techniques, we create a wrapper around the calls that we have to make to the 2 APIs we want to call. So the movie API and the magic API. And this is how a wrapper is gonna look like. So it's gonna have 2 public methods that we can call them. And this is how our application grading movies is looks like, applying dependency injection. So the initializer can take the 2 different APIs and we can pass everything we want there. And then the main public function doesn't look very different from what we had before, but instead of calling free functions, we're just calling these functions in the to dependencies that we are injecting. And how the tests are gonna look like now. So instead of using mock.patch, we can create two different mocks, which can be reusable. We can have them in the fixture. And again, as before, we can also specify the return values that they have to be. But at this time, we are not tied to exactly the implementation details of these APIs, because these wrappers that we have created return the data in a form that we really care about. And that's what we want to test in our application. So that leads us into much more readable, extensible, flexible tests. There's no danger to forget moving a mock.patch decorator with us. And we don't care for specific API implementation details. We test only our business logic and not the input and outputs of the other APIs. And as I'm running out of time, I'm not going to explain the integration tests. But the main point of my talk is we have a lot of values of what makes a good software design. This list can extend to, I don't know, a lot of lines, a lot of bullet points. But one of these values is having testable code. And this is a good enough reason to affect our design decisions and our architecture. So that was from me. Thank you for listening. You can reach out on Twitter at Olga Matoula. And also we are hiring, so feel free to chat to me about that as well. Thank you.
Thank you for your talk, Olga. It was great.
Yeah, nice topic.
I'm waiting for you.
Okay.
Yeah, thank you.
Excellent. Thank you very much.
I'm trying to convince my colleagues about. I'm
to join Bloomberg or
my colleagues about this.
To join Bloomberg or to use C++?
No, we hire Python developers as well. Not every team is C++ team. We do a lot of Python and Bloomberg.
Okay, that's great.
Okay.
So the next speaker is Daniel. Daniel, are you here?
Yeah, he just joined.
Hello, Daniel. How are you doing?
Hi.
Daniel?
Yes, I'm here. Hi.
Oh,
Can
cool.
you hear me? How am I
are you streaming
nice fake background?
Yes. Artificial Zoom background. No, I'm in my garden.
Oh, that's very nice. Lovely garden. So you're going to talk about game math in 10 minutes, right?
Yep.
Exactly in 10 minutes.
Okay. We'll present my screen. Can you see a blue screen?
Yes.
Excellent. I can't. Okay. Game math in 10 minutes. Hi. My name is Daniel Pope. I'm a software engineer for a hedge fund. So programming games is my hobby. I'm also the author of a game framework called Pygame Zero, which is based on Pygame, but aimed at beginner programmers, particularly young beginners, as young as 9 or 10. There are several books about Pygame Zero now, including Eben Upton, the creator of Raspberry Pi, has just created a book on coding the classics. And there are examples of Pygame Zero code in every issue of Wireframe, which is the Raspberry Pi magazine's game enthusiast magazine. I also organize Pi Week, which is the Python game jam. That's something I started organizing after 10 years of participating in the competition. I won it 4 times, or twice before I started organizing it. I've won it twice since. So Pi Week is an online game programming competition at pyweek.org, pyweek.org. Pygame Zero is used by a lot of beginners. I also hear from a lot of dads, and I'd like to say mums too, but so far only dads, who are picking up Pygame Zero to teach their kids to program. As a new dad myself, I can't wait to teach my daughter to program games. So if you're a parent, maybe this talk will help you. Whether you write 2D games or 3D, or use Pygame or Pygame Zero or Piglet or Arcade or my new framework, Wasabi 2D, which I'm using today, writing games will require you to apply a few basic pieces of mathematics, but you won't find them in the documentation for those libraries. This is high school maths, so if your maths exams are long behind you, this will be revision. All of my examples are going to be 2D. Wasabi 2D is a 2D framework, but everything I'm going to show you will generalize to 3D. The maths gets slightly harder sometimes. There's a whole extra degree of freedom there. So let's start with the basics. What is that? There we go. So this is a coordinate system. Here you're looking at Wasabi 2D rendering the screen, and it's plotting the coordinates of the mouse cursor as it moves. So the x coordinate, that's at the top of the screen, is the distance from the left-hand side, and the y coordinate increases downwards. In some engines, y goes upwards from the bottom left, and some people seem to get very hung up on that, as if there's a right or wrong answer. And it doesn't make any difference. The maths doesn't change. So it's like driving on the continent if you're from the UK, or vice versa. So Wasabi 2D chose to measure y downwards, like many other frameworks. Pygame, HTML canvases, SVG are all from the top left. An XY pair, so the coordinates are given above the mouse cursor there as x and y, and that identifies a point on the screen, but we can also think of that as a vector, which is a quantity that has direction as well as a magnitude. So the point on the screen is a vector from the top left, which is called the origin. You can add and subtract vectors by adding and subtracting the values of the x and the y coordinates. So perhaps you remember this little equation by a guy called Pythagoras. So the x and y coordinate directions are at right angles to each other, which makes it easier to makes it easy to construct this triangle and find out the length of the hypotenuse. So it's that formula there. I can't point to it. So we're finding the distance from the center of the window to the mouse cursor. Dx is the difference between the x coordinates, dy is the difference between the y coordinates, d is for delta. I use that convention a lot. So I can put some numbers into that, and you can see that even if as the coordinates go negative, that's the negative direction, then I'm getting a positive length. The first thing you can do with that is you can check for the collision between two circles. So if the length of the distance between their centers exceeds the sum of their radii, then those circles are intersecting. And you can see that the circle turns red as it intersects. There's a trick in when you're doing this in code, which is that you don't need to take the square root. You can just compare the squares. So the equation at the bottom, and as I put numbers into it, is just comparing the sum of the squares. So moving on to a completely different example. Here I've wired up the cursor keys to control a character. And if you imagine position as a vector and input as a vector in the equation at the bottom, then every frame I'm just adding a speed component multiplied by the input vector. But the movement there is a little bit jerky. So it's better to have acceleration. And that's what the code looks like for that. We keep a separate velocity for the object, and we add to the velocity every frame based on the input, and we multiply the velocity by the drag component to let it slow down at the end. That's actually not the code that I would write, because most game frameworks will give you a time component, dt. And so what I would do is multiply the acceleration by the time component and the drag by the time component. And what that means is that if I slow down the frame rate, then the character should hopefully move at the same speed. And that would hopefully mean that the game has the same feel even as the game gets slower, because there's more happening on screen. So that's calculating acceleration every frame. But if we just want to go from A to B, then there's something easier that we can do. And that is to simply take A and B as our start and end points, plot the course between them, and then follow that path over time. Oh, missing my notes. So if A is 0 at the left-hand side here, and B is 1, then we construct this function and scale it. The equation at the bottom right scales the function f to run over a time, which is end, from points A to points B. Once we've done that, we can plug in a different function. So here's a squared function, and that means that the object is accelerating towards the end. Or that's ease in if you are using like CSS animations. You could invert that to decelerate to a point, or use a cosine function to accelerate in and accelerate out at the end, or decelerate at the end. Or you can do more complicated things. So the function there, I couldn't be bothered to write out. But the same logic applies. But to do that, you do need to know A and B in advance, and you need to store them. So in other cases, you might want to react to situations that are changing, like the mouse cursor is moving here, and I can't store the position we've come from, and I can't store the position we're going to. So I just need to approach the mouse cursor. To do that, to do this at constant rate, I need to normalize the separation between the target I'm going to and the current position, and just take a step towards every frame. It has this annoying property that as you get to the end, it's going to start vibrating as it passes through the target and flips out the other side. So there's an improvement we can do. Improvement we could do where I just move a fraction of the way towards the target. And that's a much more zippy, and maybe you can see that the animation is smoother. You can tune the rate at which it approaches the target. And again, I could plug in a DT to make that time-based. This is the equation that the statement that I've shown there is a frame-based approach. And the last thing I have to show you is angles. So we've talked about coordinates, Cartesian coordinates, as being X and Y pairs, but you could also see them as an angle and a length. And to convert between those, we need to use trigonometry. So if I have a vector, and I'm pointing towards the mouse cursor here, then the Y coordinate is given by sine theta, the X coordinate is given by cos theta. I've got the angle theta that I'm plugging in, or a tan 2 is the function that gives you the inverse of that. And it gives you an angle in radians. So radians, forget about 360 degrees in a circle, there are 2 pi radians in a circle. That's all I have to show you. Those are the links for the things that I've spoken about. All of my slides were written in Wasabi 2D, and the link at the top is the link for the slides. Wasabi 2D is documented there. And if this is interesting to you at all, join us in September for the next Pi Week.
Cool.
Cool. Thank you for your talk, Daniel.
Nice slides.
Wasabi 2D. So what is the plan now, Alex?
So we have a short break, right? I honestly need to breathe. A lot of things going on.
Oh, you need to breathe.
Yeah. So we should make a break.
Yes. I think I prepared something in the middle. Maybe I can share my screen. I have a break slide. Okay, so we are going to have a break, and the talk is going to start at the supposed time. It should. So in 8 minutes, Raphael is going to speak. Okay. And everybody can go do whatever they need in these 8 minutes. Have a glass of water at least. Yeah, it makes sense. So
What do you have for us, Christian?
No, really, it doesn't work. I don't know why. Life is so tough today.
What's happening with Zoom?
I don't know. Just give me a second.
Well, Mark Smith could tell a tractor joke.
Yes. Let me.
I can tell a tractor joke. I can even share my video. There we go. Can you hear me?
Yes.
Yeah.
Excellent.
Hi, Mark.
Oh, there we go. Hi.
Hey, Mark.
So yeah, when is a tractor not a tractor? When it turns into a barn. See, these don't work so well when there isn't a large audience of people groaning in unison. So I have a few more of those. I'm going to tell pizza jokes first, though. So let's hope that there's no gaps between the talks. Hynek has just asked that people don't encourage me, but it's too late for that. How are we doing? This is great, by the way. I'm loving this conference so far.
Really? Is it working well? YouTube
Yeah,
and so
absolutely.
on?
It's great. And it's also just wonderful to be able to get out of bed in the morning and go downstairs and switch on the computer and join a conference. I mean, I've been missing my conference friends so much recently that this has been great.
Can you chat with them on Discord or something?
Yeah, we've already been doing that. You know, every so often somebody's been waving at me or whatever on Discord. And then we have a catch up on what we've been doing.
Hopefully they're all live and well.
How are we doing with coming up with a screen, or are we not doing that anymore?
I think Christian should turn the client on again.
Just give me a second. Can you see my screen? Can you see the break? Okay, cool.
Oh.
Yeah, great. Isn't nice?
You have fancy emojis from your fancy Mac.
We already spoke about this. It's because I paid a lot of money for the computer and you get the emoji.
My computer's not even good enough to put up a fake background, so you get my real background. Every so often somebody points at the Viking helmets on the top of the bookcase and says, "Oh, are those real? I always thought those were photoshopped on." I actually have 2 of them. If I really run out of material, I might show them to people later.
So I pip installed PyJokes, and I have some Chuck Norris jokes to share. First one is, Chuck Norris can unit test entire applications with a single assertion. It works. Thanks for laughing.
Well, anyone will tell you I have a terrible sense of humor. We're getting lots of people in the Discord saying that the conference is working really well for them. So, yeah.
Cool.
Yeah, that's great. That's also nice to hear.
Oh, and I'm getting criticism for the Viking helmet having horns on it. It's like, yes, I know that they were invented for German opera, I believe in the 18th century. I know all about Viking helmets. Thank you. I've had this as my avatar for about a decade now. How do you feel?
So from where are you speaking, Mark?
I'm in just outside Edinburgh, Scotland. We've been having glorious weather every day for the last 3 weeks, and today is the first day that's sort of grey and overcast. This is a great opportunity to stay indoors. How about you? I think I missed earlier when you said where you were at the moment.
I'm in Berlin.
And I'm in Munich.
Ah, okay. I think it's a great opportunity for these remote conferences to just sort of bring people together from across the world. It's been great to see people from sort of Asia Pacific region dialing in and contributing. It's wonderful.
Yeah, I think it's pretty cool. Although it's, I mean, it's a completely different setup compared to, normal conferences.
Yeah, but I imagine it's still loads of work.
Yeah. We spent a lot of time thinking about the streaming platform, whether using Zoom or something else. Yeah, we played with a lot of things.
30 days though, that's incredible, and all that money you've raised. It's just wonderful.
Yeah.
I'm just going to disappear for 30 seconds and grab a coffee that I just made before I sat down at my laptop.
Enjoy your coffee.
Sure. So, Christian, did you know that Chuck Norris' first program was kill -9?
Okay, something else. I mean, I was looking for jokes about programming, but with Bruce Lee, and it said no jokes about Bruce Lee.
Well, I guess you can take all the Chuck Norris jokes and replace for Bruce Lee.
Okay.
People are telling programming jokes in the question and answer channel.
Okay, let's read some of them. A DBA walks into a bar, walks up to a table and asks, "Mind if I join you?" Okay, that was that was a good one.
My favorite is a QA engineer walks into a bar, orders a beer, orders 0 beers, orders 9,999,999 beers, orders a lizard, orders -1 beers, orders a, and this doesn't work when you read it out because it's just a series of random characters. There's a follow-up to that joke, which is the first real customer walks in and asks where the bathroom is. The bar bursts into flames, killing everyone. You don't have to laugh at that one. That was from a tweet with 64,000 likes.
Oh.
Okay.
So we are on time for next talk.
So I'm gonna stop sharing my screen. Also, I'm gonna disconnect because now it's, I think, let me check. Yeah, now there is Mark, there is Timur, and there is Arthur.
Yep,
yeah,
I'm here.
So yeah, enjoy your time and
Fantastic.
see you later.
See you later.
So
one of the problems I have right now is that when I'm speaking, oh, right, now, sorry, the camera wasn't switching to me when I was talking. You go, Alexander.
Would you like to host this session?
Yep, I can totally do that.
That would be great. I hope you have your factor jokes ready. And the next speaker is Raphael Pierzina. I think he's joined us already. Yeah. Raphael, are you ready?
Yeah. Hi.
Hi.
Shall I start? Is that fine? Or?
Yeah, sure. From where are you speaking?
I'm in Berlin here in my home office. Yeah. So in Germany, it's late. Oh, lunchtime actually. Cool. Should I get started?
So, yeah, go for it.
Raphael is going to talk to us about composition over inheritance in Python. I'm really looking forward to this. Take it away, Raphael.
Thank you. I'm sharing my screen now. Let me know if you can see keynotes. Does it come up okay?
Yep, I can see that.
Cool, awesome. Yeah. So again, hey, my name is Raphael. Thank you so much for the Python Pizza organizers for creating this awesome online event during a time where everyone's movement is greatly restricted and we can't attend conferences like we would normally do. My handle on Twitter and GitHub is @hackerbrot. You can follow me there if you want. I work at Mozilla as a staff test engineer on Firefox telemetry. And today I will be talking about composition in Python. And thanks so much for Hynek for the shout out earlier today. Here's our agenda. So first, we'll have a look into what is inheritance and what is composition. Next, we'll look at a specific example based for multiple inheritance in Python based on a blog post that I published back in December. We'll look at a specific problem that can arise when you're using inheritance-based design. And we'll conclude by looking at how we can rewrite the existing example using composition instead of inheritance. So what is inheritance and what is composition? Both inheritance and composition are tools for code reuse and object-oriented programming. However, there's a significant difference. They use very different concepts for modeling relationships between the types. To me, kind of the best way of how I try to remember it is that with inheritance, you base your types around what something is, whereas with composition, you base it around what it does. So keep this in mind when we look at the code examples in just a second. I don't want to have too many transitions between my presentation and the code. So I'm reading out this code for you now, and please keep this in mind while we look at the code. It's from Brandon Rhodes, and he said this in his article on pythonpatterns.guide. A crucial weakness of inheritance as a design strategy is that a class often needs to be specialized along several different design axes at once. I highly recommend you check out this article. For the time being, please keep in mind the different design axes, and this will be very useful when we look into the code. So I'm switching over to my other screen now, and you should be seeing my code editor on the left-hand side, and on the right-hand side, there should be a terminal visible. So let's start by running the existing example for inheritance, and so you can get an idea for what we're seeing here. So we can see that there's a person called Simone. Simone goes to the movies, builds a robot, goes hiking, commutes to the office, and is then working on a project called Data Platform. She drinks some water to stay hydrated, and then she's commuting back home. Dave also works on the Data Platform. So I'm getting some audio there. Let me mute that. Cool. So Dave also works on the Data Platform, but he commutes to a local coffee shop instead of working from the office. He also drinks water and commutes back home. Chelsea also works from the office, works on the same project, but she doesn't like water so much, so she's drinking tea instead. Marlene also works on the Data Platform, but she's neither commuting into the office nor to a co-working space or a local coffee shop. She's working from home, and she also likes to drink tea. So let's look into how this is realized in code using inheritance-based design. We define a class called person, and the person has an attribute called name and provides some functionality. The default implementation for staying hydrated is coded to use water instead of tea. There are some activities defined that we saw Simone is doing. And then we can already see the first specialization, which would be our first design axis in this problem. The stay hydrated method that we define on the base class is not really applicable to people who prefer tea over water. So what they do is they inherit the entire interface of the person and then override the stay hydrated method to drink tea instead of water. The next design axis is the team member. A team member has an expertise. It's optional, and if they have one, it's included in the prompt on the command line. Then there's a default implementation for the commute, which is going to the office. And then a team member works on a specific project. They commute to the workplace, they work on the project, and while they do it, they try to stay hydrated to stay healthy. We have some specializations for the team members here. There's a mobile engineer, a data scientist, a project manager, and the operations engineer. We had examples for all of these in the code printed on the right-hand side. And the last design axis that we have is the workplace. We saw that the default implementation is that people are commuting into the office. However, we also saw that some people actually don't work from from the office, but instead they work from home, or they work from a different, like a co-working space or so. So same thing again, we use inheritance to inherit from team member, which in turn inherits from person. We introduce a new attribute called workplace, and based on this instantiation parameter, we have a commute method, which either tells us that the person is working from home or they commute into the workplace. So this kind of brings us to the problem already with inheritance. Whenever we try to combine an object along these different design axes, we have to use multiple inheritance to combine them. So we end up happening with something which is often referred to as the explosion of subclasses. We define a lot of classes. And this is what it looks like. A data scientist who likes tea is a data scientist, but is also a tea person. And this can get more extreme, for instance, here with a mobile engineer who works remotely and likes tea. A mobile engineer needs to be a mobile engineer, a remote team member, and also a person. So this brings us to this problem. We are all facing this global pandemic right now, and everyone is strongly recommended to work from home. How can you achieve this when you use inheritance and classes where everyone is something? So a person can't be a person who works from home or like works from the office, and also a person who works from home. So next, we'll see how we can do the same thing, but instead using composition. So first, the design axis that we identified, the first design axis was actually the person. And the person has a name, and for the sake of this demonstration, a person also has an emoji. The personal information of is completely unrelated to the activities or the role that the person has on the team. The next design axis is the stay hydrated. We define a protocol here, and every class which implements the drink method using the same parameters and return value will implement this protocol. And we had two specializations here. We had a drink water and a drink tea. And again, this is completely unrelated to the rest of this class. Next up, we had roles. We define a protocol again. It has an attribute called expertise, and they work on the project. Now it's up to every class to implement this protocol without using inheritance, because we're using the protocol functionality of the typing extensions here. And we could define an operations engineer who maintains system software for the project. We have a data scientist role for people who analyze data to improve the project. We have a project manager who plans and oversees activities for the project, and a mobile engineer who develops mobile applications. So this is our third design axis of this problem. And then finally, we were faced with a situation where everyone needs to work from home now. So rather than using inheritance, we just define another component on our composite class, and that would be the workplace. Again, we're using a protocol here, and that would be the commute method, which needs to be implemented. Person working from the office uses this version, home is this, and the protocol implementation for the remote people accepts an additional argument, which is the workplace. So now if we look into how all of this comes together, we define a new class, but instead of using inheritance, we pass in the different components into this composite class. So rather than that a team member is a person who works from home, they have a workplace, and the workplace happens to be their home. The same thing for the profile, which is the personal information, the role, and the stay hydrated. So in the actual implementation of work and project, we delegate to the specific component. So instead of calling self.commute, we'd call self.workplace.commute. And the same thing for the role and the stay hydrated. So we delegate all this functionality to the component which is responsible for this specific aspect or design axis of this class. So now if we run this composition example, we can see it still very much looks like the example from before. Simone goes about her activities. They all commute to their respective workplace. They work on the project, and they do something to stay hydrated. So looking at how this is implemented, the script here, we can see that rather than defining a bunch of different classes, we don't do any of this. We just have one class called team member. And we specify the different implementations for a specific component. So every team member gets assigned a specific component to the different design axes, and then they work on the project. So you may be wondering, okay, so what happens to all of the people who don't currently work from home? Well, we can, since every team member, the team member has a component of a workplace, we can set the workplace to a different implementation. And this is all we need to do. So let me just print this example here. So if I modify this so that everyone works from home and I run this example again, we can see that now everyone is working from home, in fact. Simone works from home, Dave works from home, Chelsea works from home, and Marlene also works from home. So
down to your last few seconds, Raphael.
That's fine. Yeah, I hope I was able to demonstrate that composition allows for a more flexible and robust design in this very short talk. I hope this kind of made you curious and you want to find out more. I created a back channel for this talk. It's in Pound Composition in Discord. Please ask your questions there, and thanks so much. That's me.
Oh, thank you very much, Raphael. Could one of the people assigned as a host to this Zoom call re-enable my video, because I can't thank you.
Oh, sorry.
Oh,
I should have made you co-host.
So yeah, you just get to see my name in a grey background, which I'm sure is an improvement. Thank you very much, Raphael. I think you can at least hear my applause. Yeah, so I don't have any sound effects, unfortunately. So next we have Matteo. Matteo, are you there? Excellent. I can see him going off mute. If you'd like to share your screen, Matteo, and switch on your video.
Let me do that.
Fantastic. So in just one moment, Matteo is going to talk to us about Python development for Windows. And it looks like everything's running as it should be. Are you ready, Matteo?
Yes, I am.
Where are you calling in from today?
So I'm calling from Central Europe, from Berlin in Germany.
Mm-hmm.
So nothing too fancy.
You're one of the people from Berlin.
Yeah, yeah, exactly.
Yeah, that's cool. I'm in Berlin too.
Take it away, Matteo.
Okay, thanks a lot. Yeah, so welcome to talk, everyone. I'm very excited to be here. I think this is a pretty cool format. And yeah, so I'm just to introduce myself, I'm a data scientist based in Berlin. And I've been working with Linux mostly, or actually mainly for the past 15 years or so. So just to give you some context about this talk. So at the end of this talk, hopefully I will have shown you how, what to do to use Python on Windows, and hopefully also what not to do. So the story behind this talk is that a client of mine asked me to work on some data pipeline that was processing some Excel files and then put them on some online platform or some database that's not really relevant now. I thought, yeah, this is, simple task, shouldn't be too complicated. But of course, devil is in the details, and the reality was that this was actually an extensively manual process that involved a bunch of Python scripts that were used on Windows to upload this bunch of Excel files, and was involving actually a series of manual steps. So not an ideal situation if you ask a data scientist like me, but I said, okay, that's why, that's my job. That's to help out with this and maybe improve it and make it better.
So first of all, I did some research about what does it mean to have Python on Windows? How does that work? Since I never really done it. Turns out there's a dedicated page on the official Python documentation, and well, of course, it's still 100% Python, so it's compatible. We have cross-platform compatibility, but there are some caveats. For example, the operating system does not ship with Python, so you have to download it and install it yourself. Then there is a separate piece of software which is called the Python launcher, which ensures a higher level of compatibility, for example, with the shebang lines that we use to make our Python scripts executables by the system. And surprise, surprise, there are also a few features that are unique to Windows that you don't find in any other platform. So that was interesting. That was kind of a surprise. And then, I went back to my task, think about the problem, and said, okay, but maybe, I can just take this and just put it on a Linux machine, removing all the manual steps, and forget about Windows, right? It's Python after all. It shouldn't be too hard to make it run on a Linux machine. Usually, it should be easier, if anything. So the only issue that I saw was, that the data format, the initial data format was kind of odd in that, Excel files, again, not ideal for a data scientist, but, that's what I had to work with, and I didn't have any control on the original data format. So I had to work with that. Turns out that in this case, it isn't too bad, because this is the XLX extension, which is technically called the Office Open XML, not to be confused with the Open Office XML, which is a different thing. And it's a standardized format that is readable by several also open source pieces of software, like LibreOffice, for example. So, and among others, there is a great Python library that is called OpenPyXL that can do that for you, can access the files and read and write. And I just put a little code example here. You see you can load an Excel file. It's technically called a workbook. And within that, you can select your sheets, selecting them by the name, and then you can select your value, just inputting your cell location. This is not too far from what we do with pandas, for example, if you're familiar with that. So, I was pretty happy at this point. It looked quite nice, and I was, happy that I probably didn't have to deal with Windows and, a lot of unexpected things, possibly. Yeah. But, of course, it's never like that. And, I had to take this code base and work with it at the beginning. And there was one point where it became clear that I just had to stick with Windows. And this piece of code just shows you what the problem is. So what this piece of code does is it opens Excel on Windows, and it selects your sheet. And it cycles through your sheets in your Excel file, and it takes all the shape, as they're called, in Excel, and copies them to the system clipboard. And this is basically the equivalent of doing that by hand, just using the Windows API. And then after that, you paste the clipper content to an image, and you continue with your Python business as usual.
But this crucial part is only possible in Windows because it is the famous Windows-only feature that I was mentioning before. And it's called PyWin32. So it's a Windows specific library that allows you to use most of the Windows API. So you can practically use Windows as if you were like clicking and doing things with the user interface with your mouse and keyboard, but with Python, which is quite impressive. But yeah, not very helpful if you want to avoid using Windows. So yeah, at this point, I wasn't very happy about it. But what can you do? At this point, okay, I need to have a Windows installation. I need to use Python on Windows. So I had to see what I could do with that. So I will give you, let's say, the quickest and easiest way to go to have a functioning Windows installation when you're usually working with Linux. And the two main options that I've seen are either a virtual machine, for example, with VirtualBox, or VPS on a cloud provider, for example, Windows Image on AWS. Then this is the bare minimum. You will need a Windows ISO, and you can get by with a month of free trial by downloading it from the Microsoft website. And the same you can do with Office or Excel. So this is my contingency plan, until I don't get rid of that piece of code that forces me to stay with Windows. Once you have Windows, there are a few essentials that you need for Python, and that's it. To download Python and install it, an editor. There are plenty available for Windows, so that's easy. And then Git and Git Bash. I think this is pretty essential because Git Bash gives you a pretty good terminal emulator for Windows that you wouldn't otherwise have. So at the end of this, the moral of the story, for me at least, is that this is a temporary solution. I don't really want to do this for long. I want to, migrate everything to Linux for sure. And for what I've seen, Windows is not a great platform to do software development, at least in Python, for what I can see. Of course, your mileage may vary if you use other languages. I wouldn't know. And then, I want to continue with this because it seems less than ideal, this kind of setup. And mainly, I would like to see if I can set up a Docker image that can run interpreter for me. And there is a possibility that I could replace that piece of code that extracts images from Excel files with the LibreOffice API, but I haven't quite looked into that yet. So yeah, this is it. Thank you for watching.
Thank you very much, Matteo. There's virtual applause waiting for you in Discord.
Yeah, by the way, I set up a channel in Discord if anybody wants to ask questions. It's Q&A_Windows.
Okay, great. So Norbert, if you'd like to share your screen now, and if you could unmute your microphone so we can just check your sound. Well, the screen sharing is working. Excellent, perfect.
Perfect.
So I think we're running a little behind schedule, so I will just introduce you as quickly as I can, given that it's quite a long talk title. So Norbert is going to talk to us about ice crystal impact analysis using tkinter, multiprocessing, OpenTV, and matplotlib. It's over to you.
Thank you very much. Yeah, it's a very long title, but it's rather simple, let's say. Well, it's not simple, but anyway, so I'm Norbert. I'm doing my PhD in aerospace engineering at Airbus Central Research and Technology in Munich, where I'm also sitting right now. And I'm going to show you what I did with Python and ice crystal impact analysis. First of all, I want to explain to you why we are doing this. So when an airplane flies on travel altitude, it may pass through so-called ice crystal clouds. And if the concentration of the ice crystals is high enough, they may enter the engine, warm up, partially melt, and then accrete on the outward surface of the high pressure compressor, which is of course not very nice, especially if this ice detaches and flies through the remaining blades. It may knock some teeth out. We don't want that. So what do we do about it? So first of all, we have to know how to handle this and what is happening inside this engine. Now, we could just take an engine and put it in a wind tunnel, but that is very expensive, as you can imagine. So otherwise, we can compute it with models and simulation tools, but that's where the problem is. We have not very accurate models right now. This is where our project comes in place. Music Hike, it's a European funded project, and we're trying to build 3D tools for simulation of ice crystal icing. Now we have a lot of partners European-wide, and in this project we're going from experiments to models to 3D tools and validation, and I am part of the experimental group. So basically what we are doing is we try to simulate these conditions in a lab environment, and we shoot crystals on the surface, which looks like this. We record this with a high-speed camera. Now this video is recorded at 180,000 frames per second and with a very small scale. So here, this width of the video is about 1 millimeter. This crystal is 300 micrometers, and it's traveling at around 40 meters per second. So the question is, what do we want to get out of this? Now, we would like to know where the fragments go, how fast they're going, basically statistical data, how the shapes and so on. And this is the point where Python comes in play. So we would like to have a tracking of these ice crystals incoming. We want to know the shapes, the velocities, and then basically the impact points, and finally the fragmentation. So we want to characterize the fragment shapes, sizes, and velocity distributions. We want to have statistical data like the size distribution of the fragments. And finally, we would also like to have not only one singular impact, but multiple impacts over a long time, and see where the ice accretion inception is and how this depends on different conditions. So if there's a severe condition, then maybe this ice accretion starts earlier, and we want to characterize this. And this is why we build a Python code which can track and recognize impacts. And the main thing, it's basically an adaptation of the so-called Kalman filter. We check the focus of the crystal, the travel direction, we check predicted positions and areas and so on. And so we can track a crystal over several frames. And this is harder than it looks like. And especially with our setup where we have quite large movements of crystals, even though we have such a high temporal resolution. So we have to adapt this code a little there. But as soon as we have the tracking of crystals, we can detect impacts by checking the direction, if it's changing, or the speed. Maybe it's disappearing behind the surface or sticking on the surface. And finally, to check if there's a lot going on after the impact, and we can certainly say there was a fragmentation. Now, another problem is that sometimes we have multiple crystals inside one frame, and if they're having large movements, it gets very hard to track, especially for the fragmentation. So this is where we have where we don't have tracking yet. So this fragmentation, the small crystals spreading in all directions, it's quite hard to track. All right, and we implemented this in a tkinter user interface, where we could where we could have a nice user experience. At least that's what I tried to achieve. The main processing is done in the pre-processing, so automatically the software rotates through the window images, processes them, and there we use OpenCV, NumPy, and so on, math. It then identifies the crystals, accretion, and the impact recognition. Now, this problem, that we have a problem here that we are checking a lot of fragments, a lot of shapes, and we have a lot of for loops, so it takes a long time indeed. So what I did is I simplified this code to just track some impacts without all the unnecessary other information. And since our code is not perfect, we implemented GUI to then select the true impacts and deselect the impacts where the code made mistakes. We can then also check the location temporally and spatially. And once we have that, we can calculate automatically again the angular velocity distribution. And once everything's finished, we check the histograms. Finally, we can export it with some nice matplotlib graphs and with the two Excel files. I'm going to demonstrate very quickly, hopefully, how this looks like. So I just started the software here. We select our file. Now this is a very small file with only 1,100 frames. And once we start, this goes with multi-processing through these two code snippets. Now, usually if we have 100,000 frames, this would take a long time. So the total analysis would take about 45 minutes, but this quicker solution, the impact analysis only, is around 8 minutes. Once this is finished, we can go into the manual selection. It shows us the impact. We can say yes or no, this is an impact, this clearly was an impact, this also. Here we have a flyby, so we say no. Here a crystal that impacts, but it's very blurry, so we cannot say much about this, so we say no. And finally, again, another good impact. Now, my code is not perfect, so I implemented this update button. But yeah, let's continue here. We can then select the location. Yes, it's the right frame. We select the point of impact, also the right frame, little offset in the impact position. And here it selected the wrong frame, so we move one back. We select the right location, finished. We can then do the histograms. Basically, we can skip through all the frames and see here the contours that the algorithm detected. Now, I don't know if you see it, but we have very, very small particles, maybe a few pixels large, which the algorithm does not recognize. So here we can pump up the numbers in some regions, adapt the numbers. I will just skip that now. And so we can go through all the histograms and improve the numbers here. And once that is done, we do this velocity extraction. This is depending only on the location earlier, and we can do this simultaneously as well. But for now, I did it like this. So now this velocity extraction is finished, and we can export easy. And this is also finished. So now that everything is finished, we can check this folder. Here is the original video file, and all the other files are pickle files where we can have like a temporary saving. So we can always go out of the software, go back in, and continue where we last stopped. We have all the data saved in Excel files. So from this, we can build a bigger database. We have nice graphs with matplotlib. So here, for example, we have the angular velocity distribution of the fragmentation. And yes, that's what we built. And now the question is, what does this bring us? So I could also just go ahead, take a video, and manually click through all the crystals, measure all the diameters and shapes. But of course, Python can do this way better and way more accurate. So we have now nice, accurate shape, size, velocity distributions. And we can do this way faster. So imagine if we have a 100,000 frame video, with around 500 impacts, this video only would play 1 hour. Now, if we would go ahead and do manual analysis, this would take us minimum 2 weeks. But with our new approach, we can do this in 4 hours. So we had a huge improvement here. And now in the future, this is aimed at creating a bigger database and maybe even using machine learning on this database. Because currently there's not a lot of data out there for this ice crystal things, and that's where I want to go. And that was it. I don't want to go on too long. Here's my contact data. If you want, you can also contact me on Discord now, but otherwise via my email address. Thank you very much, and that's me.
Thank you, Norbert.
Good one.
I'm just going to unshare you now, and then I can see Pablo's waiting online. So if you'd like to share your screen, Pablo, that would be great. Pablo has a very short talk title, so it won't take very long to introduce. Screen sharing, perfect. Okay, so sorry?
Cool.
Yeah,
I'm good to go.
Talk to us about Python gotchas.
Right. Thanks for the introduction. Yeah, so I'm Pablo. I'm a computer scientist from Brazil, living in Germany. I use Python since 2001. I was previously at Globo.com in Rio de Janeiro, and currently I'm at Kite Consult here in Munich. So before we move on, after this slide, that's only going to be Python code. I'll be very happy if most of you learn at least one new thing today. And I'll try not to repeat what you can find on YouTube or Google. And I might be wrong on some argument or another, so please forgive me. We'll start with filter expressions and generators. Sometimes I see code like this. It may work on most of the time, but it is doomed to fail for even numbers or an empty list, right? Not only that, if you have a costly operation there, it may spend more resources than necessary. As you can see, the costly function would be called 1,000 times only to return the second element. But other times I see better code like this, a generator being used instead, and that's good. But what happens if no element satisfies that condition? Say you want all the negative numbers instead. What's going to happen in this case? Yeah, boom. The iteration goes all the way to the end and stop iteration is raised. Well, luckily, the next built-in function takes a default argument that is returned in such cases. So you pass in the generator followed by the default value, which in this case is none. And here, yeah, you can see that it's still, the function is run 1,000 times, but there's no exception being raised. The same is valid for other built-in functions, such as any. You can pass a generator directly to the function, so it stops execution as soon as it encounters or satisfies the costly condition. So let's now talk about exceptions. The finally clause is not very used out there, although it serves nicely as a cleanup phase where you can undo things or repair, like exit in a nice way. Even though I find some uses of finally rather incorrect. And some developers can tell, for example, whether the finally block executes or not, depending on an exception being raised. So let's see how it works. Foo here is defined as a mock, and I'm going to use mock in this presentation a lot just to count the execution and assert a few things. So it is used there in the finally block. Now for the second call of log down with the key 2, as we're passing in a dictionary, a key error is raised and it is handled by the accept key error. But that happens, what happens is that the finally block is executed for both cases, regardless of an exception being raised or not. But there's more to it. Previously, we passed a dict to flog. Now we're passing a list. And there's a different exception being raised there. Now, instead of a key error, it's an index error that is, in that case, not being handled. So that is not an except clause for the index error. So whenever an exception is not handled by the try block, the finally block re-raises it. So it's going to be re-raised by the finally block. As you can see there, it is re-raised, so we needed to use a try to print the result of flog. So, but now what happens if the cleanup phase itself fails? Say a runtime error was raised while cleaning things up. Well, if an exception is raised inside the finally block, the previous exception becomes the context of the new one. And what you can see down there is a snippet of the traceback for cases like that. You have both exceptions. And the one that was raised by the cleanup follows the one that was originally raised. But that changes when the finally block returns a value. In that case, the unhandled exception, which in this case is still an index error, is discarded and things go on. So whenever you have a return or a break or a continue inside your finally block, say it's in an iteration, for example, then things just go on, the exception is discarded. So for now, enough of that, let's talk about logs. We love logs. We feel very comfortable reading them. We have them spread all around our code base, but depending on the configured log, not all of those log messages are outputted, especially those debug messages, which are very useful. But regardless of the configured level, both strings are being formatted before being sent to info and debug functions. We can see that by setting foo again as a mock and overriding its dunder wrapper function. So we can see how many times that was called. And you can see that foo gets interpolated 2 times, even though the login level is configured as info and one of the login messages is debug. Well, that's not good. That debug message is evaluated unnecessarily. So thanks to the Python core developers, the standard library provides us with lazy evaluation of log messages. This is a snippet of the function used by the login module to output logs. And you can read it, it's written in Python. It says there, the log message is formatted only if it's going to be outputted. That is, only when a log message only when the message level is greater than or equal to the configured level, only then the message will be evaluated. Here we can, again, attest to that fact by using logging functions correctly. Foo is interpolated only once. You can see there that we define still the logging level as info, and we have 2 calls, info and debug. And down below, we display how many times the wrapper function of foo was called, and it was called just once. And when I say correctly using logging functions, I mean it is the formatting message followed by all of the arguments like that. So you give a chance to the standard library to evaluate your message only when it's really necessary. So if we decrease the log level to debug, both messages are evaluated. Then you might be wondering, well, what difference that really makes? Well, Python core developers are very smart people, and they wouldn't write that lazy evaluation just for fun. It may not make a big difference in small applications, but in system with massive loads, that's definitely something to consider. So you can see there that the bug was evaluated a bunch of times, even though the logins is info, and that cost a lot more than the other one, which wasn't called. So now, enough of that, let's talk about pre-commit, if I still have some minutes. Pre-commit is awesome, and we are all using it. But you should be aware of how it runs the hooks. And the documentation is not very clear in that regard. When the files to commit or push are more than a few, the hook is run in parallel. Each process runs the same hook entry with a batch of files. They are sent as argument by pre-commit. Oops. Now, if you use a task runner such as make or something similar, you may start having problems with concurrent hooks like tests. So either you will write your make files targets in a way that they are aware of arguments, or be sure to define require serial equals to true on those hooks. So come next Monday, make sure your logging messages are not expending too much resources on your production systems, and check to see if you're not running tests concurrently without knowing. I hope you all enjoyed this talk and learned at least one new thing from it. Thanks so much for watching, and have a good one.
Thanks very much, Pablo.
Okay.
Just making sure that we're all applauding. I can at least see one other person applauding.
Cool.
So one moment now. So Geir, if you'd like to share your screen.
Yes.
Right now. Am I pronouncing your name correctly?
Yeah, Geir Arne.
Geir. Okay, so that was quick and easy. So Geir is going to talk to us about import anything, playing with Python's import system. I suspect there's going to be some dark magic here. Take it away, Geir.
Thank you so much. Yeah, so I'm Geir Arne Hjelle. I'm currently in Oslo in Norway. And this is kind of a little part of an article that I'm currently writing for Real Python that hopefully will be published in a little while. And one small disclaimer just about this talk. This is definitely things that are kind of more fun to play with than stuff you should really be doing. So I guess keep that in mind. And yeah, the idea of the talk is essentially let's have a look at what happens when we do imports. And just if we're looking at this at a high level, there are three things that are happening when you import a module. So first, the import system is looking for a module on your system and hopefully finds it. When it's found, then it's loaded into memory, and then it's finally bound to a name. And mainly I'll be talking about the finding and loading here, but first just a brief detour into talking a little bit about how the name binding works as well. And usually you would use the import statement to do this, but you can also look at the import machinery through the import lib library. It kind of exposes the same functionalities. So for instance, instead of doing an import numpy as np, you could use import lib and then import lib.import module of numpy. And what this does is that it does the finding and the loading, but it doesn't bind anything to a name. You need to do that by yourself. So in this case, import numpy as np is essentially the same as doing np equals import lib import module numpy. One small note when you do the name binding. So for instance, if we do something like from math import pi as pi, even though we just import one object from math, the whole module has been imported. I can try to ask for it just by typing math, and we'll get the name error because even though it's been imported, it hasn't been bound. So we don't, the math name isn't defined. But just to prove that it's actually there, we can have a look. So the same example, I import pi from math, And then I look into sys modules. So this works as a module cache. So that's actually a dictionary that stores references to all the modules that have been loaded. So if I just go into sys modules and I pick out math, then I can find the math module that was imported earlier, and I can bind it to any name I want. In this case, I just bind it to math, and we see that I can use the math cosine function. So the main thing, kind of the main takeaway here is just that the sys modules works as a module cache for this. Okay, then I want to talk about the finding and loading part, and a little bit more detail there. So first of all, what are the steps that are being done? So the first thing that actually happens is that when you do import, it looks in sys modules. Has this module already been imported? If so, it just uses this one. It doesn't go any further. And that's kind of a big optimization that Python is definitely needs to make sure that we can kind of import stuff without always re-importing different modules. But then for our talk, the more interesting thing is what are these finders doing? And there are actually several different finders, and each of them implements a different strategy. So by default, we have a built-in finder that looks for built-in modules. And although the one that's mostly used is one that just imports from your Python path. And then once these finders find whatever they're looking for, they return something called a module spec that defines then which loader to load the module. So the module spec essentially then, or the loader itself, defines how should a module be imported. So how should it be loaded into memory? Okay, so let's have a look in how to play with these things. So again, these things are exposed through the sys module. So if you look in sys and at sys.metapath, so this is a list of the finders that are defined. And this is kind of like a prioritized list. So if I do, for instance, import math, it will start with asking the built-in importer, can the built-in importer import math, and so on. And then for math, it will end up in the pathfinder. But sys.metapath is just a regular list, so you can play with it. So for instance, I could clear out the list, effectively just crashing the whole import system, because now I'm not able to import anything. What we would do, if I would do, for instance, import sys again now, that would still work, since that would use the cache. But for anything that needs to be found and loaded would not work after I do this. Of course, that's not really helpful. So let's see if we can do something that's a little bit more useful. We can write our own finder. So this is a short example. So finder is just any class that implements a find spec class method. So it's just a protocol essentially. And for this one, I'm just saying that, okay, whatever thing I'm asked to import, I'm just printing out that I'm importing it. For this one, I'm explicitly here returning none. And this, of course, I don't need to do that, but the idea here is just that the finders can terminate in one of three ways, essentially based on the result of your of the search. And by returning none, the finder just says that I didn't find a module. I don't know how to handle this module. And what happens then is that it just goes on to the next finders on the list. If it would actually find a module, then it could return a module spec, which would then tell the loaders how to load the module. And the third option is that you can raise a module not found error. And if you do this, you essentially just shortcut any finders that come after you and say that this module can't be imported. So one, I guess, silly use of this would be that you can do sort of like blacklisting modules, for instance. I could do a test. So if it, for instance, regular expressions are imported, I could just say that that's not allowed. Okay, so how would I run this? Well, I just insert my debug finder that we just created first in the list of metapaths. And then when I do import CSV, for instance, it would just list that, okay, I'm importing CSV, but then CSV itself imports regular expressions and other stuff. So this just gives me a quick overview of which modules are actually imported in the background by CSV. Okay, how does loaders work then? So loaders are classes that implement, again, essentially a protocol. So they implement two methods, the create module and the exec module. And what happens here is that the create module is the one that creates the module object. usually you would just return none here, which will then just fall back to Python's default module creator, which works for most cases. The exec module is more interesting. That's where you add content or functionality to your module object. And this is where we can kind of play around with it ourselves. And at least for me, one analogy that I think works fine here is that create module is similar to how you call new for classes, which is something you rarely need to do yourself. And then exec module is like init for classes. So let's see in one actual practical example of this. And this one was inspired by a very nice article by Alexei Bilogor called Import Almost Anything in Python. And what I'll do now is that I'll just add finders and loaders, which helps me directly import CSV files. So let me just start off by showing how this will actually look in practice. So if I have a CSV file like this, and then I created now some code that I'll show you afterwards that just is in a module called CSV importer. And once I've done this, I can now say import people. And this import people now imports actually the CSV file here. So I can look at the people module here, and you'll see that this comes from the CSV importer that I defined. And if I look now, for instance, at people.name, that is an attribute I define on the module that lists the name column from the CSV file. Or I could also just look at people.data and pick out one of them. Here's Guido, for instance. And this kind of works now just as a regular module in Python. So I could even do help people here. And you can see that this is the module people. It has some data on it. Okay, so how did we implement these things? Well, first of all, I need to, let's see, there's the examples. Yeah, so I define a CSV importer. And this is just a regular class that follows the protocol that I mentioned earlier. For this one, I'll add both the finder and the loader in the same class. The one thing I kind of need to pass through here is just the path to the file. So I'll keep that as an attribute here. And then once this thing is imported, I'll append it at the end of the meta path. So it will kind of be the, yeah, if the path isn't found, or if the import module isn't found anywhere else, it looks for it in CSV files. So then the find spec method here, it just looks for a given CSV file in syspath. So you can see here, we just take out the module name, convert that to a CSV file name, and then we loop through the syspath. And then if that exists here, then I'll return a module spec, essentially just being the class here, specifying that I should use the CSV importer as the loader. And the CSV loader, and that needed to define two different functions. So that was the create module. For this one, I'll just return none, again, explicitly, so that I fall back to Python's default system. And then for the exec module is kind of the more interesting part. Here, I'm just using the regular CSV standard library.
About 20 seconds left.
Yep. The CSV dict reader to read the CSV file. I'll get the data out of there, and then I'll just store everything on the module dict. And that's how it pops up as attributes on my module. Okay, so that was a quick demo of how to import CSV files. As I said, this is probably not a good idea to be doing, but it's fun to play with. The code and the slides for this one are available on GitHub. And thank you so much for your attention and the chance to speak here.
That was great, Geir. Thank you very much.
Thank you very much.
Okay, so next we have Ellen. If you'd like to unmute yourself, Ellen, and and share your screen, please.
Yes.
Ellen is about to ask us the question: do we want our tech to be profitable, ethical, useful, or reliable? So we get the thought now. So where are you calling from, Ellen?
I'm calling from Berlin as well, like many people here.
Indeed. I'm getting worried to ask the question now in case the answer is always the same. But I will hand over to you now, Ellen. You have your 10 minutes.
Thank you. So yeah, my name is Ellen, as was just mentioned. I'm a data engineer at the engineering consultancy ThoughtWorks. And I've been working in tech for about 10 years now as a data engineer, as a software engineer, and as a data scientist. And one of the common threads in my career, and I believe it's something that, especially for people that attend conferences, is also something common in your career, is a passion to build high quality software or technology. And so today I want to dig a bit deeper into what do we actually mean by software quality? What is that, and when we're talking about it, and how can we get to it? And about 15 years ago, I was studying at the University of Potsdam in this exact lecture hall. And my professor I was studying computer science, and my software engineering professor was asking the class, so we talk a lot about software quality. What do you consider to be good software? And there were a lot of interesting answers. So there were a lot of answers, and I summarized them into 3 groups right now. So one of the groups said reliable in all sorts of ways. And other people said it's interesting to build. And then yet other people said it's financially successful. And so back then I was wondering, being fairly new in computer science and not having given this topic much thought so far, who of us is actually right? So all of these things seem kind of valid, but I don't think we can achieve them all at the same time. And so then I started digging deeper into this topic, and I found, when I wrote my master thesis in computers about software architectures, the answer is it depends, which is a classic consultant answer, which is very close to my heart as a software consultant. And it actually depends on who you ask. And so in the literature, you find different groups that have different opinions about what good software should look like. And for instance, one perspective is the one that is very close to my heart, for example, is from engineers. And for me, it means things like software is maintainable, it is tested, it has high availability, and all these things that kind of make a software nicely constructed and running well. And it doesn't have defects and all these kind of things. But quite a different perspective is then if you ask me as a software user, then I have a very different, or often a very different perspective. Then I'm more concerned with, can I do something cool with the software? Does it help me do things in an interesting way? Is it fun to use? Is it suitable for the purpose I have? But there are even more perspectives that we can look at. For instance, one that might be very familiar to those of us that, like myself, are professional software developers, is that of our clients and our management. And by the way, there's a slight subtle difference between the client and the user, because especially when we talk about enterprise software, the client is the person that's buying the software, but it's not necessarily the person that's using the software. And so then from this very business-oriented perspective, the good software is actually one that the client is willing to pay for. So good quality meets the requirements of the client. And is that what they're willing also to pay for? So what is financially sustainable? And yet, from a wholly different perspective again, and that's a perspective that wasn't widely discussed when I was studying computer science, but what is coming up more and more these days as our society is becoming more and more aware of the implications of software. So there are questions like the ethics of algorithms. So as a society, we ask ourselves, is the software platforms we're using, are they adhering to our ethical standards? Are they meeting our political requirements? Are they ecologically friendly? So what is the footprint of all these servers that we're running? Are they trustworthy? Are they respecting our privacy? So all these kind of the concerns are yet another way we can look at the quality of our software. And to me, the interesting question is still, who decides who we are building for? So in the ideal world, all these concerns and all these perspectives on quality are really aligned, and we have this one perfect software thing that is ethical, that's maintainable, sustainable, it's financially successful, and it does everything we want it to do. But I guess anybody on this call which has probably experienced it, in most cases, these things do not always perfectly align. And then the interesting question to me is, which perspective wins? So, and when we go back to the screen, I found that in many cases, the answer is actually pretty straightforward, and it's not as difficult to answer as I originally thought when I was an engineering student. And so the fact is that, at least for most of the software is built in companies, and most of us engineers rely on getting paid either as a freelancer or as an employee. And so eventually the perspective that dominates the way software is being built is is the financial perspective, so the perspective of our clients and our managements. And so the software is good when the client is willing to pay for it. And to me, that was quite, when I thought about this was quite a surprising conclusion. And but it makes a lot of sense. And I would just like to encourage you to also reflect yourself from your own professional experience. How does this work? So I'm really curious to hear your feedback then on the Q&A channel, what your experience has been. How well does reflect your experience? Is it really always the client and management perspective, so the financial perspective that defines how well the software is being built and what is considered to be good software or not? But for me, then the next question after I had this conclusion was, how can I still have an influence on the software that I'm building? And there's a bunch of different perspectives that some of us apply to us as engineers, some of us apply to us as users in society. And there are ways, and I don't have a very strong thought or position on any of them yet, but I just wanted to throw them into a kind of teaser, into a discussion. And so one of the things that's a very classic engineering approach is hacking. So that's where the whole idea of open source and free source comes from, that free software comes from, that we can take our software, if we have the source code, and modify it to our needs, make it more useful, make it more maintainable, make it more available, or whatever we want it to be. So as an engineer, we have some kind of potential influence on the software if we are able to modify it. That works to some extent, as we've seen. I mean, otherwise we wouldn't be talking about on a conference about open source software. But it's also quite limited because it's a very privileged position in a way to be able to modify your own software and be able to have the time and the money and the skills to modify it. Another thing, what we can do, especially as tech people, because we're actually in a fairly comfortable position, maybe not in the current economy as much anymore, but generally, because we're sought after specialists, we can actually negotiate. That's where all these discussions about tech debt come from, and the discussion we probably have as engineers every day with our product management, our senior management, etc. These discussions about how to reduce tech debt, that's what is, how do we define our architectures in a way that they're sustainable and that they're maintainable, and all these kind of things that make us proud as engineers and also make our lives easier on the long run. And but again, this is it's a bit of a luxury situation that we're in, and I think it's something that we should be aware of and use the luxury to as much as we can. But then there's also situations where we might not be able to build the software ourselves or modify it ourselves. And then when we're purely a user or purely on a social level using the software. And then we talk about things like legislation, which is surprisingly controversial in software. I'm not totally sure why, because in other consumer situations like medicine, food, transportation, etc., these are all very popular things to make sure that the software meets certain social and user friendliness standards. And I think it's again something that we should consider more. And finally, but certainly not least, is just to pay for our software. That sounds obvious, but there's a surprising trend to make it not obvious, because as the saying goes, if you're not paying for the software, you're not a user, you're the product. And so as soon as we start paying for our software, we're in a much better position again to negotiate about what we want to see in our software and how it should look like. And I'm only touching this very briefly, so if you want to dig deeper, please feel free to reach out to me on Discourse, or I also wrote a blog post on this, which you can find on my blog, or just tag me on Twitter. And I really appreciate being able to share this thoughts with you. Thank you very much.
That's fantastic, Ellen. Thank you very much.
Thank you. It was wonderful.
You get claps from 2 people, and then there'll be more applause in the Discord, hopefully.
And I should.
So that was perfect. Yes, please. That was perfect timing as well. So we are back on schedule, which is great. So Konrad, you're next. If you'd like to unmute and share your screen.
Of course. Hi.
Second. So Konrad is going to talk to us about dependency injection in Python, which is, I think, matches quite nicely with some of the talks we've had already about how we compose our software. So here we go, dependency injection with Python. Konrad, all yours.
Cool.
Hi once again, my name is Konrad Hałas, and today I want to demystify the topic which is surprisingly barely known in the Python community. I hope that after my presentation you will know when to use and why to use dependency injection. Before we start, a few words about me. I'm working at Crosscheck, where we are building ad text tools for airlines. I'm also a co-organizer of Python Warsaw user group. I have a few open source projects. I also gave a few talks and trainings. So if you want to check my stuff, please visit my website. You will also find this presentation there. So let's start with some assumptions. It doesn't make sense to use techniques and tools which I will show you today in every product you have. They are designed to solve specific problems, and maybe you don't have these problems in your project. So in most cases, such technique or tool adds some extra level of indirection, let's say. So there is a price you have to pay, but if you use it wisely, there is a reward too. My approach during this talk is that I don't want to bore you with some definitions that are detached from reality. Instead of that, I will show you a simple app which will refactor together in a very small steps, and I hope that after this presentation you will agree with me that dependency injection and dependency injection containers are very useful things. So our app is a pizza ordering system with a JSON REST API. In our example, we will focus on a single use case, placing an order. I put our code into 3 modules. Web, which contains everything related to HTTP request response processing. Business, which is responsible for anything related to the business logic, and DB. Here we have a code that stores data in the database. So let's start with web. In a web module, we have a single function which is attached to orders endpoint. As you can see, I'm using Flask-like syntax here, but it doesn't matter which web framework you choose. The most important thing is that we take data from request and we are passing it to place order function from business module. Order is a simple class with fields like customer or pizzas. Next, in business module, we have a single function too. For the purpose of this example, it contains only a single call of save order function. But this is the place where you can run our business logic. So in this function, we can validate that customer reached minimum order value or that we can deliver pizza to the submitted address. We also execute here steps from our business process. So let's say we can notify one of our restaurants that they have new order to deliver. But for now, for the sake of simplicity, let's only save the order in our database. DB module doesn't have anything interesting for us right now. The most important thing here is that this is the place where we are calling our database. So that's all. We have 3 modules with a very simple flow of data. But as you probably realized, business module is the most important part of our system. So let's focus and let's focus on this module and let's check how tests for the modules look like. This is the simple test of place order function. Because in our example, place order function has only single call to save order. So this is what we are testing here. But I hope you can imagine that place order function can be much more complicated. And there will be many more important things to test here. Because it's not a good practice to call a real database in our tests, we have to use mock patch to replace save order function with the mock. But unfortunately, mock patch is not a good practice too. Of course, it works, especially when your code base is small, but from the architectural point of view, it's a hack. User of place order function doesn't see that it will call a database. He has to know the implementation to call a proper mock patch. But, well, we can fix it. Very simple. Instead of importing save order directly, we can add this as a parameter to place order function. And this is the basic form of dependency injection. Our place order function has an external dependency. In our case, it's save order function. And instead of direct import, we are injecting into our code this dependency. It increases flexibility and readability of our code, and we don't have to use mock patch in our tests now. So as we know, explicit is better than implicit. Cool, but it's not the best solution too. Now, parameters list of place order function is a mix of input data and dependencies. It doesn't look good. Fortunately, there is a simple solution too. We can transform our function into a class and use _init method to capture all dependencies. Now it looks really good, but we can do better. This callable types hint, it's not the best solution. It's very limited. It works only with very simple cases. So for example, what if our safe order function needs some dependencies too? Again, solution is quite straightforward. Let's change safe order function into a class in the same way as we transformed place order function into order service. So we end up with something like this, and we are almost in the clean code heaven. But there is one more thing to fix, and it's related to the import statement, which we have in our business module. This import statement is pointing to our DB module, which is not the best solution. As you know, we have 3 modules in our app. Business module is the most important one. It implements core logic and processes of our system. So we can say that it's a high-level module. It shouldn't have a code related to technical details like web framework or, let's say, maybe database. What's more, it shouldn't depend on such code. There is a principle that says high-level modules should not depend on low-level modules. We call it dependency inversion principle. And if you heard about solid principles, it's a D letter at the end of solid. And because we have this import in our business module, we violate the dependency inversion principle. It should be like that. What we can do? Instead of relying on concrete implementation, we can define the interface we require from our dependency. In the Python context, it means that we have to define abstract base classes or protocols. And this is the final solution. We have a code which is decoupled from low-level details, it's flexible, and it's easy to test. Awesome job. The thing is that now we have a bunch of classes instead of simple functions. We have to instantiate our objects and combine them together before we can use them. In a simple system, we can make it manually. We can create a single module where we instantiate and bind together all dependencies. Very simple solution. But what if our object graph is not so simple and we have to create and pass multiple values? This is the moment where we should use dependency injection container. DI container is a tool which, based on type information we provide in _init method, can instantiate an object of given class. When we ask to create instance of order service class, DI container will check list of its dependencies. In Python, it's a list of _method parameters, and it will realize that to create order service object, it needs to create orders repository first. So what it will do next? Well, it will check how to create orders repository in the same way, and at the end, it will build instance of order service. Of course, it's not simple. It's not always so simple, because we introduce some interfaces, some abstract base classes into our code base. We have to tell the DI container which implementation we want to use if somebody asks about given interface. Here we have a configuration of injector library. It's one of dependency injection containers for Python. As you can see, it's not so complicated. You just have to bind your interface with concrete class. Now, if some class in our system will need orders repository as a dependency, injector will inject concrete implementation. And last move, to use our container, you just have to call get method to create order service instance. You then have to provide dependencies on your own. Container will figure out how to create these objects for you. Yeah, and so that's all. In these few simple steps, we transform our functions, simple functions, into classes, and we introduce DI container into our project. Of course, now our code is a little bit more complicated, and this is the price we have to pay. But on the other hand, it's much easier to deal with such design in more complex applications. I hope you enjoyed.
Thank you very much, Konrad.
Thank you.
So, a round of applause, I think.
Thank you.
Thank you.
That was 5 seconds short of 10 minutes. 10 minutes is such a difficult time format. And it's so great when people meet it that close. See you. Right, so next we have Anastasiia. If you could unmute and share your screen.
Yeah, hello.
Hello. So where are you calling in from?
I'm calling from Berlin.
Ah, fantastic. Another Berliner. We've had a lot of people from Berlin and Munich.
Yeah, of course. And I have a beautiful pizza background right now.
Oh, you do? You do? Oh, you're making me hungry now. And I haven't ordered pizza, so I'm one of these people who won't be having pizza today. I almost made pizza, and then I thought that maybe emceeing part of the conference and speaking at it and making pizza was maybe just too much for one day. Okay, so I think we're just about to hit time. So giving a talk about the hidden truth of soft skills and making them work for you is Anastasiia. Take it away, Anastasiia.
Yeah, hello everyone. Thank you for having me today, and thank you for organizing this beautiful conference. There are so many awesome speakers. I mean, everyone is awesome, and I will talk a little bit about vulnerability as well today, which is also one of the soft skills. And I do feel vulnerable when I go on the stage, especially today when I have no eye contact and I don't have direct feedback. I cannot connect with people, so I'm just like talking to my screen all the time. But I will try to help everyone to sort everything out about soft skills. A little bit of my background. Why am I even talking about soft skills? I have different experience of setting up the team, also helping the team with the Scrum and building safe environment for everyone. And in the Scrum, there is also one really interesting ceremony, which is one of the core, I would say, meetings from Scrum. It's a retrospective meeting when everyone has to be honest, and before making this possible to be honest with everyone, you have to make not just this meeting, but also talking to other people safe, so nobody would be blamed and nobody would be ashamed to talk. So let me go through the soft skills first. I would also list here which soft skills are required for a team member and the team leader. I noticed that for a team member is also a big list of skills needed, and in every job listing they're kind of hidden because every team has already established traditions, already established ceremonies, and of course to fit into the team you have to know all of them. So as a team leader, I sometimes also do interviews, also not just technical but the team field culture questions, and to get to know person if it would be a good fit, I'm checking which soft skills they have. So for a team member, you will have to have communication, collaboration, ability to learn, creativity, accountability, adaptability, flexibility, a lot of abilities. And for a team leader, it's a bit more. Basically all the same for a team member, and also ability to establish trust, communication again, decision-making, problem-solving, business focus, ability to give context, ability to hire and motivate, ability to keep calm and execute, protective instincts, and ability to recognize your own weaknesses to be able to improve. So basically there are lots of skills required, but what are the most important, as no one can really learn everything, especially at once. Today, we are working all remotely, and especially for remote jobs, we have to build trust with people somehow remotely. So for that, we need to decide how to speak with them, how to communicate, how to approach them. It's not so easy to just come by somebody like by the table and ask for a coffee meeting, or maybe ask to go out for lunch. We have to do something right now. We have to set up a meeting, we have to communicate, we have to talk. So in order to develop your soft skills, you have to, first of all, define your own values. You have to also establish trust between all the team members and not just your team members, but also people you communicate with. And for that, you have to show your own face. How are you in the real life, not your mask, of course. You have to be shame resistant. I will tell about this a bit later. And also you have to know how to create a safe environment at work. Then you have to deal with difficult conversations. Of course, even with Corona times, you can have difficult conversation and the heating ones. And also you have to be able to provide radically candid feedback. Let's take a look where to start. As I already mentioned, the first one would be to define your own values. Please take a look at all of these values. The full list you can find in internet, just search for core values. And your task, first of all, is to define 2 of them. Of course, it's really hard to define 2 core values because maybe you will pick 5 out of 100, that's already something, but it's even harder to keep them. Because of that, just try to pick 2 main ones, the ones which drive you at work and at home, basically in all your life, and try to keep you. For example, if you decided to pick respect and courage, so be respectful no matter what. Be respectful to your colleagues and also to people who are not directly connected to you, maybe who have different opinions, and of course in heated conversations as well. After you define the core values, you can go further, of course. If you know core values of your colleagues, that would be easier for you to know which language of appreciation they would appreciate, basically. There are 5 different languages, and different people, they would like to see how you appreciate their work, whatever they did for you or for the company, or maybe how good they are at the job. And you have to know how to approach them. So the first one is words of affirmation. A lot of people, they really like to hear something in words like, you are really doing a great job, you're really great in this position, and your soft skills are great as well. Sometimes people appreciate quality time, meaning that they would love to be invited for a coffee meeting, or maybe for a team building, or maybe some kind of event. Then acts of service. If this person you know likes acts of service as a language of appreciation, then make sure that you offer her or him your help, but in the way that this person would appreciate, in the certain time that a person would appreciate that. And physical touch, it's also one of the important points. Some people appreciate a handshake or a hug, and also some people like gifts, but it doesn't mean that the gift should be only physical, it could be also time. Quickly into vulnerability and boundaries by Brené Brown. I highly recommend to read her book. Vulnerability is the emotion we experience during times of uncertainty, risk, and emotional exposure. It's having the courage to show up, fully engage, and be seen when you cannot control the outcome. For example, attending a Python Pizza conference. I highly recommend you to read this book to learn more about this, but make sure that you don't overshare. And for that, you have to define boundaries. There are lots of techniques, and I'm running out of time. I will quickly go through them. So start slow, do not overshare, mind what you're sharing, and then be sure that you defined this certain level of sharing with your colleagues. Shame resistance is very important to build a safe environment at work. So you have to be resistant to your shame. And you can also read about this in Brené Brown's book. And feedback session. It's really important to give a proper feedback, and the idea is to care personally and challenge directly. That means that you have to show that you care about the person and to sort of remove the protective shield between you and this person to establish trust. And then you have to clearly say what went wrong, what could be improved. And I highly recommend you to go through all of the books to read how to establish a certain culture in the team, how to what to do in the crucial conversations, and how to get to know more of your colleagues. And if you would like to get more, I can post also a link to my blog post where I wrote about all the soft skills. And thank you.
Thank you very much, Anastasiia. And a round of applause for me as well.
Thank you, thank you.
I think very, very important to have these conversations about ethics and soft skills and all of the stuff that goes around the technology. Certainly when I started in this career, it was just about producing stuff, and I wasn't worried about how, you know, the process and the people involved with producing things. I've gradually become educated over time, and it's made me better for it, I think.
Thank you so much.
Thank you for your talk.
Thank you.
So up next we have Miro. We're actually running ever so slightly ahead of schedule. But if you'd like to share your screen, Miro. So a fun fact was the original version of the schedule on the website had a photo of Miroslav up instead of me for my talk. And I guess we're just two kind of bald men giving talks at Python Pizza today.
So can you hear me?
Yes, I can hear you.
Can you see
You're a
my
little
screen?
bit. Yes, I can see your screen. We are a couple of minutes early. Where are you calling in from today, Miroslav?
I'm in Karlsruhe. Karlsruhe is the southwestern of Germany, next to the French border.
Excellent. So, well into lunchtime, I guess, at the moment.
Oh, I'm already after lunch.
I believe Miro once said that this is a place where the best French beer and the best German wine.
Yes, exactly. But now the border is unfortunately closed.
Everything's closed except for remote Python Pizza. So I guess is this a talk about internationalization in some way?
Not really, no.
No,
until now my talks were quite international on local conferences. Now I'm giving a very local-based talk on an international conference. So it will be very different from the talks before.
Fantastic. Yes, that's obviously what you're known for, is talking about internationalization and character sets and things like that. And introducing as many different languages into your talks as possible is always very impressive.
It will be boring today, everything in English.
Oh, that's such a shame. I was hoping I might learn something. So I think I'm going to let you start now. So with a talk entitled Python, Let's Go Home Quickly, is Miroslav. Take it away.
Thank you. So my name is Miroslav Šedivý. I live in Karlsruhe in the southwestern of Germany. I work for Zalute here in Karlsruhe, which is a company behind the price comparing portal Billiger.de, and we are one of the sponsors of this conference. I'm going to speak today about one of the greatest achievements or inventions of the humanity. Sorry, wrong picture. Here. Okay, it's a city. City is something that humanity invented and which allows great improvement of culture, of science, of economy, and of human life altogether. And another invention was built about 400 years ago. In Paris, it was Le Pont Neuf, which were the sidewalks. Sidewalks on a bridge were the possibility to separate traffic in a city, which was dangerous for pedestrians and the pedestrians on the other side. Going around in the city is not like a labyrinth. You have quite many possibilities how to get from A to B. There are more possibilities. I mean, there are really a lot of possibilities. And if you commute every day to work or go to shops or visit your friends, if you are allowed to, it's always a good idea to take a different route so you can also see something different, and it's good for the brain to switch the routes. But sometimes you just need to get somewhere quickly. to get home quickly, to get to the work quickly. And then you ask yourself, hey, how can I get there quickly? If you accidentally have to take a car, you just enter the address where you want to go, and then you get into the traffic jam, and then you just go at the speed of all other cars. There is no other choice. But if you are taking something like a bicycle, then you can get a possibility or navigation. You get some information how to get from A to B. If I use this on my cell phone, go from the Karlsruhe castle to one green area in the city, it proposes me two roads that one of them is on a very busy road. I don't want to cycle there. Another one crosses the zoological garden, and you are not allowed to cross it on a bicycle. If you take OpenStreetMap, is a little bit better, but still there are some minor details that are not optimal. So if you take a trip every day or quite often, you already know which route would be the best one. But which one of them is the fastest one? Here I see that I would need something like 13 minutes, but is it me? Is it you? Who is going to need 13 minutes to get from A to B? Distance doesn't tell much because everyone is a little bit different on bicycle. Someone is fast and can go, faster. Some are slower. So the distance is not really the good measurement. Time is better. This is at the French-German border. In Germany, you see the touristic distances are in kilometers. In France, they are in hours and minutes. This is walking minutes. But on a bicycle, it's very different. Everybody has a different speed on a bicycle. And it is not only the speed on a free road, on a really free road, or on some other very free road, but it's in the city. So for example, here, where would you go? On which side of the rail? On the right side, where there are doors of the cars, or on the left side, where there are cars behind you that are not allowed to overtake you anyway? How do you react in other environments in the city? On bike lanes that are compulsory, but they are quite narrow. Where there are obstacles on the bike lanes, where the bike lanes are again narrow, or where they are not possible to cross anyway on bicycle, but you have to go there. So everyone gets a different speed. So or also on the lights, how fast are you going to accelerate on these lights? Where are you going to put yourself? How are you going to react to other obstacles or to some provisional roads? Or when there is some other vehicle in front of you that you don't want to overtake. Or when there are self-driving cars where you can't make an eye contact with the driver. How is going the door open in the next few seconds? Or maybe the city is just doing a very bad job with all the painting. And there are other ways or other possibilities where your road is not going to be possible. So is I just roads or trips that I take on bicycle. Then I save it as a GPX, XML, download it to my computer, and then convert it to other format, to CSV that is a little bit faster to be downloaded. I get a CSV file, convert it from longitude latitude to UTM format that I'm going to explain later. I can, of course, use some GPXP, UTM, or GeoPandas libraries to do that. And why I'm using UTM? Because it's longitude, latitude, it looks much better on the map. You can just take X and Y, you get the meters, and the error is so minimal that it is no problem to measure the distances even without special geographical libraries. This is what I get. These are two crossroads. My GPX tracks, but most of the things that you can see are the circles with the error. Fortunately, when I put away the error, it looks quite well. I can identify the tracks that I took, and I have to calculate the points of crossroads. Currently, I'm just putting them manually, but maybe there is a good way to do that automatically. So what I do with these tracks, there is a crossroad. So I put some nodes with radius of 30 meters, which works quite well for a GPS tracker. And then I create a graph in Network X that connects all these possibilities, all these ways between these roads that I have taken. If there are also some crossroads that are where I have to wait a little bit longer, so there are lights or there are some turn restrictions, and I see that I cannot turn. So I have to create extra nodes within these nodes and then calculate the time, because it is not the distance, it is the time that is important. How quickly I'm going to get from one node to another one. This is how it looks on the bridge across the Rhine River. You see that for the bicycles, it is not so easy. It is not as straightforward to get to the bridge from some places. There are some places where you have 2 or even 3 levels. So tracking automatically which GPS tracks belongs to which one is not so easy. There are also some other 2 levels that are not so problematic, because you see that you are just going to cross this bridge and there are no crossroads. At some rond-point, circle roundabouts, you can put always the dot in the middle, because you are going to take this roundabout anyway. At the larger roundabouts, you have to play with the dots, with the nodes a little bit more and put them around. And all around, this all is actually about connecting the dots. So I have my dots, and I want to find the fastest way between the dots that are not still not connected. In the network X, I have a graph, and when I want to get from A to I, don't have also to go from A. So for example, there is one trip that I took from A through C to I. Another one, the blue one, goes through G. There is a third one that has a common segment between A and B and between H and I. And that gives me more information about my trip. How long was my trip between these 2 nodes? That's useful because sometimes on the street there may be lights, there may be lights, there may be some obstacles, something, and it means that I have to take a segment several times, many times, to see statistically how fast can I get through this segment. Also, when I take some other roads, there may be common segments that will maybe tell me that from A, D, E, F, I, is this the fastest road from A to I. Statistically, with Python 3.8, there is a statistics library written this, where I can just put all my measurements in minutes or in seconds, and it tells me, okay, this is the probability how fast, how fast you were able to go. And it's then to find the best trip, it is important to say, hey, do I want the fastest road? So on every segment, take the fastest time I needed, or do I want to make sure that this that I pass through this segment in less than a certain time? Because, for example, this green line is, for example, a main road through the city with some lights, because it's sometimes I need 5, 6, or 7 minutes. And this is a little bit longer road through the park, but where there were no obstacles, so I always could go at the same speed. And then statistically, I see that if I want to be the fastest in my segment, the main road is okay. But if I want to make sure, the park is a little bit surer. And this is how it looks like. I like this road much better than other navigating systems gave me. This is what I want to do. If you have idea how to do it better, or there is some better program than what my idea was, tell me, share with me your ideas. So I will put it on GitHub, and maybe that could be a nice software. Thank you very much.
Thank you, Miroslav. That was fantastic. Round of applause for you. It's not getting any less weird. 1 or 2 people clapping at the end of the talks, but it's nice to get some sound for that, right? So that was pretty much on schedule. So we've got a couple of minutes before Alexander's talk. So Alexander, if you would like to unmute and share your screen so that we're all set up.
Yes, I'm unmuted now.
Yep, I can hear you.
That's very
and
good.
I can
very
see
good
you.
To see you. Yeah, very good.
Yeah, it's been a long time.
Yeah, a year again, and we won't see each other this year. Yeah, let me share my screen.
So just for the benefit of the audience, Alexander and I see each other at conferences every so often throughout the year. And obviously with everything gradually shutting down or going remote only, we've missed each other for a while.
Yeah, and you joined MongoDB now.
Yes, I am at MongoDB, as everybody will learn at. So yes, I think we're ready for you to start. So if you're okay,
yes,
Alexander's
I'm
going to tell us 10 things we should know about Spacy. Take it away.
Yeah. Okay. Thank you very much. Yeah, there's 10 things about Spacy. I'm going to explain what Spacy is actually. So this is just a wrap-up talk suitable for beginners. So if you haven't heard about Spacy, you will know in a minute. Let me start at the very beginning. Although it's zero index, this is like just the preface. Natural language processing. Natural language processing. We nowadays have to deal with an avalanche of unstructured data, like the internet, lots of text, everything's digitalized. So the data has also conquered the text space for quite some time now. And Spacy is one of the great tools that can help you, like getting knowledge out of huge corpora of text to classify documents and do many great things all around natural language processing. Natural language processing, the abbreviation, if you don't know, is NLP. Unfortunately, there's also like some manipulation technique called NLP, which likely, if you Google it, will come up first, but anyway. What can you do with NLP? So let me just start with some things you probably don't know. There's chatbots, there is like text analysis. I think one of the best solved problems nowadays is actually the translation, like a machine translation is now at a very high standard, and you likely use it on a daily basis already. Chatbots, voice assistants, speech to text if you want to like dictate something in your phone, or like if you want your computer to read something to you. This is a whole NLP space. But there's more use cases. For example, let me show you like it's another use case. So natural language, as always, language is getting information across from one person to the other, and nowadays I'd like to add in a more or less compact way. So for example, this was one use case we had recently. We had a huge corpus, and we had to make it like not only searchable but also like create an interface so our customer could navigate through its large research corpus to find similar documents and to get new ideas from like decades of research. Yeah, it's just like a little example. There's a decent NLP alchemy toolset around. You probably heard of NLPTK, Natural Language Processing Toolkit, which was like 4 years ago, probably like the best toolkit around to work with NLP. And if you know a little bit more about linguistics, it was all very rule-based, like grammar, like it was linguists put a lot of effort in like making up rules and like accounting for all exceptions. And like a few years ago, the statistical text analysis totally took over, because also language is a moving target. Language is always changing, new words, new generations. The youth develops usually a certain different language. Now globalization, we pick up words from other languages. So it's not a static thing. The actually statistical approach was very successful. The statistical approach is to look and inspect large text sets, or corpora as we called it, and get knowledge from out it, like summarization, classification, and so on. And just not just recently, also a few years ago, also like deep learning has conquered the space. So there's frameworks like Elmo or BERT who are really good in helping you with natural language processing nowadays. So if you like natural language processing, I'm Alexander C.F. Hendorf. I'm a partner and principal consultant at König Do. We often do natural language process and NLP projects for our clients with different tasks and outcomes. This is a little bit, this is our company. You probably heard about it. We are very active in the Python community. We support the local PyData community, and also like a community sponsor for PyCon DE and PyData Berlin. What is Spacy? Spacy actually was started in 2014 from Ines Montani and Matthew Hannibal, and they had a very different feeling about natural language processing, because at that time cloud was actually the way everybody said, oh, natural language processing is going to be in the cloud, and they said no, it's not going to be all cloud-based, so that's why they built Spacy. This is a picture of them. So actually they founded their own company, Explosion AI. They're very dedicated to the product, and everything's open source. They also have some extra products you can buy, which also connect to Spacy. And yeah, so Spacy is a very stable open source library. You can totally use Spacy. It's been in the making for a while. It has a huge community support. It receives constant updates, and it has many advantages. It's fast and efficient. It's intuitive, although a little bit overwhelming. You could call it, say, it's the pandas of text. Yeah. It's relatively simple, intuitive to get in. But it can be quite extensive. So the more you want to get out of Spacy, the deeper you have to dig and learn. It supports many things out of the box, which I'm going to show you in the basic building blocks of Spacy. And I also added for the ones who are not like in the NLP space yet, some more explanation. So tokenization, which is basically just segmenting text into word, punctuation, exclamation marks and stuff like that. Part of speech tagging, so saying cat is a noun, scratched is a verb. Lemmatization is, for example, like cats to cat, scratched to scratch, just like now. Sentence boundary detection. Hello, Mrs. Poppins. It's not just like it's an exclamation mark, for example, here. You have to account for abbreviations in the NLP space as well. A very important feature is entity recognition. For example, say Mary Poppins is a person, but depending on the context of your document, Apple might be a company and not the fruit. And natural language is quite easily. Serialization, which is actually just a fancy word for saving the work you've done and to read it back in and to work with it. You can do dependency parsing, see how the different tokens or words, as we say, depend on each other in a sentence. It also supports many other things like entity linking. So we have like multiple words for the same thing. You can basically point them to the same identifier. You can train your models, extend them, update them. You can classify text, and you can also like add, for example, something like rule-based matching. So you can have like, if you have like simpler rules, you can help Spacy. Help Spacy to understand better. So Spacy comes with models. So what are models? Or let me start with language support. So Spacy supports many languages, like tons of them. I didn't count. It's at least 50 or even more. But it's only language support, and the language support is simple rule-based languages. Language support. So this is more like general. It does not cover too many exceptions. So you might see probably some weird stuff there. There's language models, and if you don't know like what's a language model now, an language model is actually a pre-trained model on a lot of text. And you basically move the words into a vector space, and at the right-hand side you can see like an example, like the most famous example here. You build word vectors, you put them like in a matrix space, and you can see like the distance from king to man is like queen and woman, and so you can get things into context. There's a whole list on the webpage. I think one thing which is important to see, you have to really look into which Spacy model to use. There are large ones, smaller ones, medium-sized ones, which one you want to use, because like the larger, the more memory it will take. And not all models provided by Spacy support all the same features. So please have a look at the documentation first before you really build on or count on that something is there. Spacy is very Pythonic, so a good understanding of Python objects, iteration, comprehension, classes, and methods is very helpful to get a better grasp on how Spacy is actually working internally, because it offers you many access points to its internal data structures to make it readable with nice method names, which are very descriptive, so the code is readable. A very strong feature of Spacy is actually pipelines. So Spacy comes with default pipeline, which uses the tagger, the parser, and the entity recognizer. You can see that below in the picture. So basically, we give it a text. We create an NLP doc, as we call it, on the right-hand side, and then the pipeline takes care of parsing the text, getting the info out, and labeling its contents. So you can customize these pipelines. You can add features, extensions. You can also deactivate permanently or temporarily parts of the pipeline, and always think about more is not always better. Like if you don't really have use for parts of the pipeline, deactivate it, because it will not only speed up your program, speeding up means also saving some energy, so it will also be considerable. Serialization, fancy word for saving. So we can save NLP documents. So the NLP document it's not just like a text file you can save. So you have you need to take care of the model. You have to take care of the vocabulary, everything you have calculated in your pipeline. And yeah, so Spacy uses actually Pickle. So it's built in the Python standard library. So if you don't know Pickle, Pickle is just like persisting Python objects. You can read and write from it. And actually we're saving bytes here. We're not saving text. You can of course also export stuff as JSON. That's also built in. But yeah, so you can, of course, if you start your project, you can just work on your disk space, or if you have a larger project, please, yeah, you might consider a database. Here, okay, danger zones. I have to speed up. The privacy, data is always biased. Also consider legal. For example, some countries have forbidden to mine judges' rulings. The language is never perfect, so always consider that language is to be considered. Want to rule all the languages? No. Main research is in English and Chinese. Other languages differ in complexity, so if you see fancy things online in blog posts, likely it's in English, but it won't work if you're not an English speaker. Extensions. There's an extensive Spacy universe, as they call it. I listed the web page here. You can add Displacy or Hugging Face. There's a lot of stuff like neural co-references, where you can have co-references and replace, for example, Lady Gaga and the singer, these references between each other. There's also bugs or things which are not compatible. This is the final point, and probably one of the painful points if you go really deeper into extensive stuff with Spacy. Spacy as such is well maintained, but the extensions might really depend on a very specific Spacy version and might not be updated as well here. So please look into it, document it well, and you have to might want to consider workarounds or using two pipelines to do all this. So thank you very much. Stay healthy, eat healthy, and yeah, thank you.
Thanks very much, Alexander. That's great.
Thanks, Alex.
Thank you.
So it's now the lunch break. So we have an hour to eat pizza, and then we'll all be back here at 1300 UTC to see Łukasz talk about Starlet. I'm going to go and get some lunch. I don't have pizza, so I'm probably going to have some cheese on toast with maybe some cherry tomatoes as the closest thing that I can put together in my kitchen that's a bit pizza-like.
Maybe add some pineapples.
I have a whole pineapple sitting in the fruit bowl. There's no lie. Enjoy your lunch, everybody.
All right. Bye.
Bye.